Then we can, yeah, then we can have a question answer round after that. But my you can say sincere request to all the participant is, at any slide, if you have any you can say doubt, okay, looking at the vast topic and the content it has, I'll just have a request. You just note down the slide number and note down your doubt, whatever you have, in some piece of paper, and then in the question answer session we can discuss it together. Okay, so that there is no discontinuity in the flow. Okay, fine. So you have your doubts. All your doubts are welcome. Only thing, we have a separate session for this question answer. Okay, so let us complete the content first. Okay, and just note down the slide number, and just we can have a reference of the slide number where you have doubt. Okay, yes. Okay, so fine. Shall we start?
Yes, Prasad sir. I think it's good to go with.
Yeah. Okay. So first introduction will be given by my colleague, Mr. Rahul sir. Okay. Fine. And then after you can say sufficient depth, then again I'll teach the in depth of the onboard charges and all. Okay. Yeah. So Rahul sir, let's start.
Okay. Thank you, sir. Thank you so much. First of all, very good evening to all of you. Thank you all for joining this session. I know you must have few questions around in your mind where about charging technologies, what is happening in electric vehicles, how charging is happening, what are the different chargers are there. There is AC, DC. What is the difference in between those? So our today's motive, today's objective will be covering around, will be touching all these points, and we'll see how well we can know something about charger infrastructure in India, especially in India. And also we will have one more aspect, which will be the job based and the entrepreneurship based aspect of charging infrastructure. Because obviously, why are we here? Why are we learning about it? Maybe most, I think 90% of you will be having uh, this output, that after this session you'll have some sort of knowledge, and then you can pursue with that knowledge and maybe get generate some sort of revenue out of it, right? So we have kept the session in that way only. Obviously it is going to be informative, it is going to be a little bit technical also. As Prasad sir has already mentioned, that if you are having any questions, any doubts regarding any of the thing in between whatever we are teaching or telling you, you can just write it down, the slide number and the topic. Even you can do it in the chat box also, so that later on when we'll be having the question answers session, in that part we can cover those doubts, right? So I think we are good to go. I'll just share my screen and we'll start with the session today. Just give me a moment, everyone. So I hope my screen is visible to all of you, right? Uh, so let's move on. Today we will be learning about and studying about electric vehicle charging technologies. Okay. So let's basically talk about the learning objectives of today's session. So we have written down what are the key aspects that we will be covering today. So the very first thing is AC/DC charging. What is AC charging? What is DC charging? We'll be giving you a gist of it, right? Then we'll be going towards the level of charging. What are the levels of charging that are present in the industry as of now? Then the next thing we will be touching is type of charging connectors. So what are the different type of charging connectors are available in global market, not just in India, but in global market, right? So we will be learning about those also, and we'll be also seeing which of these connectors are being used in India. So and one of the connectors that is very famous, we'll be talking about that as well in depth. Then we will be moving ahead with the onboard and offboard charger. So what is the difference between on and off onboard charger and an offboard charger? Then we'll be going further deep into the onboard internal circuit. So that will be onboard charger internal circuits. Okay. And in the last aspect, we will be covering the business area and the job perspectives, where we will be talking about some business aspects which is related directly related to our charging infrastructure, and a lot of job opportunities in this particular field. What kind of job opportunities are there, in which departments the job opportunities are there, and how you can pursue about it. So we will be covering all these major things in today's session. So let's not waste any more time, and let's start with the first thing over here. So, what is an EV charger for you? So, obviously, this was our first question. What is an EV charger? How would you know what is a charger, right? So, to be basically defining it, a very small definition is a device which converts AC into DC to charge the EV battery. And this is not just for EV battery. This is for any sort of battery, right? You can like, for say, you have a battery pack. It can be lead acid battery pack, it can be lithium ion battery pack, it can be any chemistry battery pack, right? So the battery itself require DC, right? It requires DC current. So to charge itself, it will not charge on the AC. It will only require DC. So you have to give it to you have to deliver DC to charge your battery pack, right? And charger is that particular medium which basically converts that AC into DC and sends to the battery pack, and that is how your battery pack charges. So this is the same exactly similar principle we are using in the electric vehicles as well. But the only thing changes over here, I would not say changes, but the only thing which is altering over here will be in our electric vehicle whole infrastructure. We will be having a multiple power electronics components, which will have inverters, which will have converters, DC-DC converters and all, and whatnot. So multiple things are there. So we will be going into that depth as well in today's session, right? So I hope as of now you just have an idea what is an EV charger. So just like you are charging your phone, your laptop, it's like that only. How you are charging your phone and laptop, it's just the same. You have to charge your vehicle as well, right? So if we talk about like 20 years back, we wouldn't even thought about it. Okay, we will be charging our vehicles and then covering the distances. But 20 years from then, now definitely we are doing it. India is actually booming in electric vehicle industry, right? The EV revolution, which is coming in India, has started with two-wheelers, electric two-wheelers, and now slowly and steadily we are also moving ahead with the four-wheelers and commercial fleet as well. With the the fleet owners with commercial aspect, where we are basically utilizing electric vehicles in payload capacity also, right? For to cover maximum distance, right? So yeah, we are basically moving ahead with almost every sort of uh, area where the transportation is required, right? So moving on, let's talk about some basic definitions in EV industry. First, what is an EV? EV is an electric vehicle, a vehicle that uses one or more electric motors for propulsion, partially or fully with the help of energy storage device. Energy storage device is your battery pack. Now, over here, we have talked about uh, propulsion system, which is partially or fully help. So what is partially, what is fully? That means electric vehicles are not just the vehicles with electric motors, but there is another aspect of it, which is hybrid electric vehicles, or we can say PHEVs, which is plug-in hybrid electric vehicles. That also comes under the same category, where a motor and engine. Both of these propulsion systems interact together and basically do the requirement thing, which is taking your vehicle from point A to point B. So it is basically making the transportation easy. Right? You must have seen electric vehicles on the road, and you definitely have seen hybrid electric vehicles on the road as well. If you want, I can also give you an example. Like in India, there is Toyota's Urban Cruiser High Rider. That is one of the example of hybrid vehicle in India. Then there is another example, which is Toyota Innova High Cross. That is another example for hybrid vehicle in India. Right. So these are some examples of hybrid vehicle. Then obviously, if we talk about electric vehicles, there are multiple vehicles from Tata, from Mahindra, from BYD, from MG. Right. All of these manufacturers are basically playing a very big role into the revolution of electric vehicles in India. Right. The next thing over here we'll be talking about is EVSE, which stands for Electric Vehicle Supply Equipment. So this is something whenever you will be talking about charging infrastructure or electric EV chargers, you will hear this particular term, which is EVSE, a lot, because it is mainly related to your charging infrastructure. Over here, you can also read control the transfer of electricity from local power supply to an electric vehicle so its battery can recharge safely and efficiently. Right. So that means the whole setup from grid to charger to vehicle to your battery pack. So everything, this whole cycle has a name which is called EVSE, which is Electric Vehicle Supply Equipment. And then later on, the next part over here we have charger couplers slash plugs slash gun. So what is that? It is a mean of enabling the manual connection of a flexible cable to an easy for purpose of charging in the traction battery. That means on the right you can also see there is one connector. Okay, this is basically known as the coupler or plug or gun. So this directly connects to the vehicle port. So this will connect to your vehicle. Your vehicle will be having a female port, and this is the male type port. So your vehicle, so basically this gun directly connects with your vehicle, and then your charging starts. Right. So these are few of the definitions that you should know about when you are basically understanding about electric vehicles and charging infrastructures. Okay. Now moving on. Let's talk about few of the charging methods. Actually, not just few, but here we will be covering almost every charging method that is there as of right now. Okay, so there are majorly three methods. One is conductive charging, second is battery swapping, and third is wireless charging or inductive charging. Okay, so in this, let's talk about the conductive charging. So in conductive charging, we have three levels: level one, level two, and level three. So what are these levels? We'll be basically learning about these in the next slide. Okay. And there is no other level for battery swapping as of now. Battery swapping, as the name suggests, which means you have to swap your battery. You have to take out your existing battery and swap it with the new one, which is a charged one. Okay, as of now in India, we have seen that battery swapping is very popular in two-wheelers and three-wheeler segment. Mostly quick commerce dealers are basically using these vehicles which are equipped with battery swapping technology, and they go to a swapping station and then just check which of the battery is ready to use. And there is an integrated app for those swapping stations as well. They just check that which is the battery, which battery is sufficiently charged. They just take out that battery, put their old battery to the docking station, and then they are good to go. So the whole process is very seamless. Even if you'll go to one of the battery swapping station nearby your area, you will find out that the whole process will hardly take 5 minutes. It would hardly take 5 minutes to just to remove your battery from your vehicles and put it back in the docking station and take the new battery which is completely charged or maybe more than sufficiently charged, and then you can put it back into your vehicle and you are good to go. You are back on road. If you are driving for, say, you are covering a very long distance, for say you are covering around 50 kilometers, 60 kilometers of distance, and you need the battery, you need the range for it, right? So there will be no hindrance in your whole journey. You can definitely, you can take a break of 5 minutes, and then in that break you can swap your battery and definitely you're back on the road. So battery swapping is, we can say, one of the very emerging field in a whole electric vehicle industry, right? But the only problem, the only challenge that we are having with battery swapping is swapping the batteries for four wheelers, because obviously those are quite heavy. If I talk about any of the battery pack which is there in the smallest vehicle in India also, that would also weigh somewhere around 200 or maybe 300 kgs. So it is not practically possible to take out that 200, 300 kgs of battery pack and put it into a docking station and then uh, take out a different, like a charged battery pack and put it back into your vehicle. Right. So we need to have one like a complete system for this particular swapping. Things are still happening. It is still in the developing phase, and there are companies which are also working on this particular area as well. But again, if we talk about battery swapping, yes, it is one of the emerging field in a whole electric vehicle industry. Then moving on to the last method, which is wireless charging. So I hope you know what is wireless charging, because we in today's world we are living in the world where like we have phones which are basically wireless charging enabled. So most of the iPhones that are coming in the market, and Samsung phones and multiple brand phones also, they are all coming with the wireless charging technologies, where you just have to put your phone on a pad and that is it. Your phone starts charging itself, right? So similar kind of technology is also being used in the EV industry as well. So the technology that we are using in the electric vehicle industry, which is the inductive charging technology, then it has capacitive and resonant inductive also. Okay, so resonant inductive is also, as of right now, is being tested in Michigan, Detroit. Okay, so that is also happening. There are multiple companies, there are multiple manufacturers which are constantly working towards these different methods as well. Now, moving on. So so in the conductive charging, you can also you can see that the chargers, the conventional chargers, we have the AC chargers, DC chargers, your home chargers. So those comes under the conductive charging, and the inductive charging is basically when we are charging the vehicle through a wireless technology, right? And battery swapping, I have already mentioned how battery swapping is happening. So on the left, right hand side, topmost picture you are seeing, this is basically a battery docking station where you put your old battery and take out the one which is completely charged. So this is how a docking station would look like. So let's talk about wireless charging. In wireless charging, as you can see on your screen, there is a picture. Uh, where there are two pads. One pad is on the ground and one pad is in the vehicle, right? So that the pad which is on the ground is called transfer coil, and the pad which is inserted in the vehicle is called receiver coil. So basically the inductance which is being generated over here is basically generated in between these two pads in these two coils, and through these coils the connection is established and the charging is happening. So I can just give you an example of iPhone. You must have seen uh, this thing, the advertisement of an iPhone, where when they launched the wireless charging, so you know that every iPhone has a magnetic ring on their back. So that magnetic ring over here is the receiver coil. Same is the case with electric vehicles also. So there will be a receiver coil, and then there will be a transfer coil, which will basically charge the vehicle through the wireless technology, right? So now we can basically see the principle behind wireless technology. So as I've mentioned, there is primary coil, which you can say transfer coil. Then there is a secondary coil, which is the uh, receiver coil, right? So this is how your whole so basically your 230 volt or maybe 240 volt AC supply comes to the primary coil, and then it interacts with the secondary coil, and as soon as it interacts with the secondary coil, it goes to the rectifier and controller to basically convert AC to DC, and then as soon also it converts AC to DC, and then also do the PFC, which is power factor correction, and then it let goes the energy which is coming from these coils to the battery pack, and this is how your battery pack charges through wireless technology. Now there is a drawback over here, which is, as of now, the wireless technology is considered to be the slow charging technology, where the vehicle will be charging on a very slow rate. Right, you can charge your vehicle definitely, but then the vehicle will be charging on the slow rate. But again, as I've mentioned, as soon as this point, we are talking about these wireless technology, but at this point only, there are multiple manufacturers and company which are constantly working behind this particular drawback, and they are trying to come up with a solution where how they can charge the vehicle fast or maybe at a moderate speed, just to overcome this drawback, because wireless technology is again going to be one of the future trend in electric vehicles. For say, like there is one more case study about it. There is there's a company in Michigan, Detroit. They have deployed a smart road of around 400 meters. So that company, what does they do? Basically, they have installed these wireless charging pads in that road, inside that road, and they are constantly testing vehicles, electric vehicles on that particular road. So on a 400-meter road, they are testing if the vehicle is charging while the vehicle is in the motion. Right. So this is also basically working on. People have started working on these kind of things as well, right? So the possibilities are limitless. You just have to expand your mind. You just have to expand your knowledge, and then there are multiple things there which you can see, because obviously electric vehicles are going to be the one of the biggest revolution in entire world, we can say, right? And also we all want to bring the carbon footprint down as well. So this will also help in that particular aspect also, right? So moving on. So the levels that we were talking about in the conductive charging, which is level 1, level 2, and level 3. So in level 1 and level 2 are basically stands for AC charging. So in level 1, you will see only AC chargers, and in level 2 also you will see AC chargers. But DC chargers basically consist under level 3. Okay, so in level 1, you'll see the chargers which are specifically around 1 to 3 kilowatt. Okay, which will give you a charging output of 1 to 3 kilowatt. You'll find these level 1 chargers with the vehicle when you buy the vehicle from any of the dealership, and they'll give you this very small charger with the vehicle, which comes with the vehicle, right? So that comes under the level 1 charger. Then we have level 2 chargers, which basically ranges from 3 to 19.2 plus kilowatt. So basically, these are those chargers. I don't know if you have this experience or not, but if you go to any of the dealership in India, for say Tata, Mahindra, or BYD, or mg, they'll offer you a charger of rating about 7.2 kilowatt or maybe 11.2 kilowatt. So they will definitely ask an extra amount for that particular charger, and they'll tell you that this charger comes under the it will basically charge your vehicle fast, right? So you definitely want to give a little bit extra amount for this fast charger, which will also keep your battery pack safe, but charge your vehicles on a very faster rate. That, let's say, if you are charging your vehicle with level 1 charger and you're charging a vehicle with level 2 charger, you will see the difference in charging speed of almost around 40 to 50%. So yeah, level 2 chargers are those which are basically giving an output of 3 to 19.2 kilowatts. Then we have the level 3, which is DC charging, right? So DC charging starts from 10 kilowatt and goes up to 400 kilowatt. Right. So in DC charging, basically you are charging the vehicle through DC. Right. Here there is no AC. You're charging the vehicle through DC. That comes under fast charging and super fast charging. Right. And later on, you can also see the type of connectors we are using for all three of the levels. So in level 1, that is slow charging. We are using connector type 1. And what is that? We'll also look about it. In level 2, in slow charging, we are using connector type 1/2, and in fast charging, we are using the type 2 connector. Then in DC fast charging, we are using GBT, CCS2, and CHAdeMO. And when we are talking about super fast charging, so in that we are using Tesla supercharger. So as of right now, Tesla is the one which are basically using the super fast chargers, and they have already named it as Tesla superchargers, and they are giving it the output of about 350 kilowatt. Right. So that is the only, as of now, manufacturer in the world which is giving this much. Obviously, there are multiple manufacturers also there which are pushing through more than 350 kilowatt also. But the first one was Tesla only. Now, moving ahead, we'll be learning about the connector types. So obviously, when we have talked about the connectors, right? So what are these connectors and where we are using these connectors? So let's talk about that. So on the left, you can see type of charging, which is AC or DC, right? And here we have type 1 and type 2. Type 1 is for 1 to 3 kilowatt, and type 2 is for 3 to 22 kilowatt, right? In here you can see there is one J1772 type 1 connector, which uses in North America, Japan. Similar kind of connector is being used in North America and Japan. Then in the Europe and rest of the market, we are using the type 2, which is also known as many keys, which comes under IEC 62196 slash 2 standards. This is another type, which is type 2. Okay. And this would look somewhat similar like a GBT connector. So GBT connector is specifically for China. Other than China, I don't think there is any other country which is using a GBT connector. So obviously, because China is one of, we can all say that China is one of the pioneer in electric vehicle industry. So they also use their different type of connectors as well. So GBT is there. Then all markets except Europe are basically using these Tesla connectors as well. Where in the area, in the country where the Tesla is operating, you will find these kind of Tesla connectors definitely, right? And in India, we are again using type 1, and many keys type 2 also we are using. So both of these types we are using in India as well. Right. because obviously in type 1 we are using for slow charger, and type 2 we are using for fast charger, comparatively fast charging, right? And then we talk about the DC charging over here, which is for higher power output from the chargers. Okay, so over here you'll see the first picture you'll see is CCS1. Okay, and the next one over here is the CHAdeMO. So, and then later on we have CCS2, then again GBT for DC. Okay, so there is a difference between GBT for AC and the GBT for DC. Okay, so and in India, what we are using basically CCS2, CHAdeMO, and GBT also. So not a lot we are using GBT, but mostly we are using CCS2 and CHAdeMO. So, and we will be going into further discussion about CHAdeMOs and GBTs on and each of these connectors also, right? So moving ahead, so the first connector you'll see over here is J1772 connector type 1 pinout. So over here you see the connector and you see 5 of the ports. So each of this port is stands for something. Okay, and what is that? So over here we have L1, we have N, we have PP, PE, and CP. So what are these things? Let's talk about that. So the L1 stands for line 1. Okay. Uh,
Control pilot.
the L1 stands for line 1, which basically gives you a single phase AC. Then the N stands for neutral over here, right? Obviously, you want to have a neutral as well, right? Then we have CP. CP stands for control pilot. Post
Yeah, no issue. I guess I'm audible. If
Yes,
Rahul's
sir.
network is not working, no problem. I'll continue from here. Don't worry. Okay. When he'll resume back, then he will continue. No issue. Okay. Let me share my screen. Okay. Is my screen visible to you?
Yes.
Yes.
Yes. Okay. 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 So, sir might have taught you about this, correct? Connectors. Okay. Fine. So here, a very simple way to remember is what is the difference between CCS1, CCS2. Okay. What is type 1? What is type 2? You have to just think what is your supply source, whether it is a AC source or whether it is a single phase AC source, three phase AC source, or a DC source. Okay. So if you segregate in these terms, single phase AC, three phase AC, or DC. Based on that, you can easily remember the connectors. If you talk about the type 1, okay, it's a single phase AC. Okay, type 1 is, hello. Yeah, type 1 is single phase AC. Okay, so wherein these three are what your earth, P, okay, and phase and neutral. Earth, phase, neutral, and one is CC, other is CP. Correct? Control pilot and proximity pilot, PP and CP. Okay, so this is type 1. Okay, and then in type 2, if you check many cakes, what happens? AC, the source is three phase now. So it is compatible to single phase, three phase also. Okay, so you have RYBN. Okay, correct? Okay, that is line 1, line 2, line 3, and neutral. You have earth, and you have again CP and PP. Correct? Okay, got it. So single phase type 1, three phase type 2. Okay, fine. And same is the case for GB/T AC. So it is also a three phase. So it can connect to three phase. Okay. Now what difference does it bring? If you have this kind of connector, okay, type 1 connector, okay, so that means your onboard charger onboard charger rating will be less. Okay, it has to only convert single phase AC with less power rating. See, correct? Type 1 less power rating, 1 to 3 kilowatt. Can you feel the difference? Okay, type 1, 1 to 3 means what? The onboard charger rating will be less. Okay, if you have a 3-phase source available, then your onboard charger should be as such that it should convert 3-phase AC to DC. Okay, so that you will get that much power output. Got the difference? Two major difference between type 1 and type 2. Type 1, AC source available is single phase. Type 2, AC source available is 3-phase. Okay, fine. And in CCS1, now these are combined. Okay, combined charging system means what? It can have AC also and DC also. So CCS1 means it's like DC plus type 1. You can break it up like this. DC plus type 1. So DC is there. Okay, so you have connectors for DC also, and you have the same type 1 connection like J177 type 1. Okay, that's how CCS1 will work. Now CCS2, again, CCS means DC plus type 2, CCS2. So DC plus type 2. Check, it is similar to type 2. Okay, fine. And CHAdeMO is the only connector which is only for DC. Okay, now can you compare type 1, type 2, CCS1, CCS2, GB/T AC, GB/T DC, and CHAdeMO. Okay, I hope Rahul sir is back. Okay, no.
Yes, sir.
Okay, so you want to continue from this type 2?
Sure, sir. I'll just continue and then we can move ahead.
No problem. No problem. Yeah. You are presenting, or I'll continue the presentation?
Sir, I'll present only.
No problem. No.
त्याच्यात जाग आहे ते मिठाई बिठाई घेऊन
I hope my screen is visible to all of you.
Sir, sorry for sir, sorry for interrupt. I am candidates DIYguru. I can sorry interrupting, but September 24 batch also can in this can enroll, no sir, means they can participate on this webinar, correct?
Yes, Tilak. Actually, it's open to all.
Yeah.
As you
Because
are aware,
in this subject, I am thinking that it is there or not there. That's why I need to know, sir. This EV charging related.
yeah, see, it's open to all. Whether you are already a student of DIYguru, not a student of DIYguru, doesn't matter. Okay.
Okay.
Across all Indian country also, this webinar is being held for all participants. Okay.
No, sir,
And-
now in coming time, I use sir outdoor, it will start offline lecture also. And it's better to means participate, no, get to know what is this, and hope we will get recording also of this section.
Yeah, sure. It will be actually put it up on the YouTube channel also. Don't worry.
Yeah. Thank you, sir.
Yeah, Rahul, so you can continue.
Okay, sir. So I hope my screen is visible to all of you.
Yes,
Okay.
sir.
Yeah, so the type 2 connector that we are talking about is actually having, again, most of the things we have, Prasad sir has already.
Sorry to interrupt. Type 1 has been not completed. It is pending. Can you continue from type 1?
Sure. Yeah. So in the type 1, you have seen, as Prasad sir has also mentioned about CC, PP, and PE, right? So let's talk about that once again, what is here. You can see there are 5 ports. In all those 5 ports, one is the line one where you get your single phase AC supply. Then one is the neutral port. And the third port over here is the CP, which is control pilot, which is specifically for post insertion signaling. Then we have PP, proximity pilot, and PE, which is protective earth, full current protective earthing system, right? So L1 and neutral should be clear to you, right? And let's talk about CC, PP, and PE. The PP over here, the proximity pilot checks if the vehicle connector is connected properly to the vehicle inlet. If the connection is not properly established, the proximity pilot will detect it and the entire process will be disabled for safety. For say you have connected your vehicle with a charging station and you have connected the charging gun also, but the connection is not established properly, right? The ports are not aligned properly, or maybe there is some issues. Okay, so in that condition, if the PP is not there, definitely you are going to start the charging. The charging process will takes place, and it might end up in a very a wrong way, where maybe you'll have leakage, voltage leakage or current leakage, any kind of thing will be there. So just to have this safety precaution, we have like not we, but the manufacturers have put PP over here, which is the proximity pilot, which basically ensures if the charging gun is connected to the vehicle properly or not. The second thing over here is control pilot, which is CP, and it is used for controlling the charging current. The control pilot continuously sends a pulse width modulated or PWM signal. So this PWM signal is similar that we are basically getting in the motors also, BLDC motors as well, right? In this way, it tells the car the maximum current that can be drawn from the charging station, that is I max. Okay, the car then draw the desired current as long as this value is smaller than the maximum current. For say the maximum current that the vehicle can draw is about 150 amps. Okay, so it can the CP, the control pilot, will ensure that the car should not go till 150 amps. It will basically draw below 150 amps only. Okay, it should not cross 150. So that 150 amps is basically the maximum current over here. So control pilot is there for another safety reason, right? If it, for say, if the vehicle is drawing more current in this condition, then obviously overcurrent situation will be occurring, and then you end up like your battery will go bad over here, and you might have different sort of mishappenings with the battery pack. Anything could happen, right? So we basically, to eradicate all those situations, all these kind of scenarios, the control pilot and proximity pilot is there. Then the last thing over here, which is PE, protective earth. Pin charger protects user from electric shock and protects electric vehicles from overload. So if there is any overload condition, it will try to put all the voltage to the earth only. So you must know what is the role of the earth thing over here, right? So it is basically for that purpose only. Now moving on to the type 2 connector. So we have studied about CP, PE and PP. Then we have AC1, which is again, here you will see three ports for three-phase supply. In the previous one, we have only seen single line port, which was for single phase. Here you will see AC1, AC2 and AC3. Here you will have three-phase supply. And then one will be the AC neutral pin. Okay, so you want one neutral and three phase supply, and then three of these pins, three of the special pins, which is one for control pilot, one for proximity pilot, and one for protective earth. So in entirety, you'll have in type 2 pin connectors, you'll see these six ports, where three of them will be using for your AC supply. One is for sorry, not six, seven. Three of them will be using for three-phase AC, one will be using for neutral, and three of them will be using for these special pins, CP, PE, and PP. Right? Now moving on to the CCS1 DC connector pinout. Again, you'll see similar kind of ports, L1, N, PP, PE, CP, right? This we have already talked about. Now in here you will find one more, two more connectors, ports, which is DC plus and DC minus, which will basically give you the DC output, right? And it will basically give you DC output to the vehicle, and the vehicle will be charged from DC, right? So this is just one addition in the DC connectors. So what is there? You the type 1 connector, and with that type 1 connector only, we have basically included DC power output with these particular connector, and then this becomes CCS1 DC connector. Now, what is CCS1? CCS1 stands for Combined Charging System. Okay, so that means with similar kind of connector, you can charge your vehicle through AC and DC both. Right. For say you have one gun, one connector, which is CCS1. Okay. And you have connected this, you have given it the single phase only. Right. In this way, you can definitely charge through AC supply, or you can charge it through DC charger as well. Right. So this is why CCS has developed, where in the similar pin layout, you can charge your vehicle through AC and DC together. You don't have to put AC chargers different, like in a separate area, or DC chargers on a separate area. So also to eradicate multiple ports on your vehicle, this is CCS1, CCS2 have been developed. Now, moving on to the CCS2 connectors Pinout. So in CCS2, you will see, again, in CCS1, we have seen the single phase. Here you will see three phase. So in three phase, on the left, you can see the female part. On the right, you can see the male part, right? Over here, both of these will basically combine together. Okay. So we have L1, L2, L3 is for your three phase lines. Then we have neutral. Then again, CC, PE and PP is there. And again, the DC plus and DC minus is there. So there's nothing new, but again, one thing which makes it CCS2, not CCS1, is basically it is running on three-phase supply, and the CCS1 was running on single-phase supply. Now moving on to the CHAdeMO connectors. Okay, so CHAdeMO connectors are basically for fast charging only and for DC type charging only, right? So over here you'll find different sort of pin connections. So the first thing you'll see, which is FG, which is for ground reference. Okay, so which is for grounding. Then we have SS1/SS2, which is charge sequence signal. Okay, basically it will start like it will signal for the sequencing of the charging. Okay, then NC port is there, which will basically tell you if it is connected or not. Then we have DCP, which is charging enable. If charging is happening, it will basically this will ensure this particular point, which is DCP. Vehicle grants EVSE permission to connect to the power, right? Then we have DC plus and DC minus, which is obviously giving you the power supply, right? Then we have PP. PP is proximity pilot, right? We have already talked about this one. Then we have CH or CL. This is basically the communication with vehicle bus to the establish, oh, sorry, communication with vehicle bus to establish operational parameters. Basically, this will communicate with vehicle and with the charger, so that it will communicate, the charger will communicate with the vehicle, and vehicle will communicate with the charger, and then establish everything is perfectly fine. All the safety parameters are checked, and signals are happening. Everything is fine. Now you can start the charging. So that way, we base why this particular thing is there, because obviously this is used for fast charging setup only. So in that way, obviously, if you are charging your vehicle with a fast charging setup, definitely there will be high voltages, high power consumptions also, right? Power output will be very high in that condition. So you must have to be very secure about the premises around you, and also the process that is happening, the charging process that is happening at that particular moment. You have to be very secure about it, right? Then moving on to GBT. So now over here, GBT 2023.4. Okay, so here you'll see CC, CP. CC over here is for charging confirmation pre-insertion signal, which we were calling PP. Okay, so proximity pilot, right? So it is I would not say similar, but kind of similar. So CC stands for charging confirmation pre-insertion signaling, before inserting. CP is for control pilot, which is for post-insertion. Then again L1, L2, L3 for your three-phase AC. PE for protective earth, N for neutral. Right? So I hope GBT is also clear to you. Now, this is AC GBT charger that you will see. Okay, now we have GBT in DC also. So I think, yeah, this is GBT in DC. Over here, you'll find mostly the similar things, which is like PE is there for obviously your protective earth. Then you'll see CCS2, CCS1. These are charging confirmations. S plus and S minus is charging communication, which is CAN based. Okay. Then DC plus DC minus is for main DC power, right? And A plus and A minus is for auxiliary DC power, which is approximately 30 volt and 20 ampere. Okay, so this is somewhat a DC GBT connector would look like. Okay. And then last, but I think this is the last one, which is NACS Pinout. So NACS stands for North American Charging Standards. Okay, over here you'll find DC1, DC2, or line 1, line 2. Okay, and we have ground, we have CP, control pilot, and we have PP, which is for proximity pilot. So in almost every connector type, you will find CC, PP, and PE. If not PE, then grounding you'll find. If not grounding, you'll find FG, right? But these three pinouts you will definitely find. And then the differences will come with AC or DC or single phase AC or three-phase AC. So the differences will come according to that, and also on basis of the communication. Okay, so this is how your different sort of connectors look like, and how you can basically distinguish between different sort of connectors which are present in the global market. And these are called the adapters. So these adapters are basically specifically designed for the vehicles which we are basically importing, or for say you are getting a vehicle for say in India, that if you are getting a vehicle which is CBU, completely built up unit, this vehicle is being manufactured in some other country which is using a different sort of charging standards. For say in India, we are mostly using CHAdeMO and CCS2, right? And you're getting a vehicle from directly importing the vehicle from China, and they are using GBT. So and the port in your vehicle you are having is the GBT type, but we don't have any chargers in India. For say for an example, I'm just telling you, for say we don't have any GBT type chargers over here. So how will you charge your vehicle, right? In that condition, these adapters will come. So you already know about type A to type C connectors in your phones, right? So it's similar to that, where you are basically charging your phone through type A to type C connector. It is similar to that, where you are charging your vehicle from type 2, like from GBT to type 2 connectors, or maybe CCS2 connectors. So this is something which is also there, which is also present in the EV industry. Right. So now I would like to put my voice on hold and ask Prasad sir to pitch in for the further part.
No problem. Yeah, thank you, Rahul sir. Thank you. Okay, let's. I'll just present my screen now. Okay. Yeah. So basically, I'll be talking about the EVAC, okay, and the onboard and offboard chargers. I hope my voice is okay and the screen is visible to you. Yes.
Yes.
Yeah. Okay. So this is a classification of your EV charger. Okay. Based on energy source, we call it an AC charger or DC charger. Okay. Then based on charger installation, whether the charger of the vehicle is inside or outside. Okay. Or if it's inside, we call onboard charger. If it is outside, we call offboard charger. Now, there is one question from my end for you. Okay, just quiz kind of. Okay. Have you seen any two-wheeler electric vehicle having onboard charger inside it?
Sir, Bajaj.
It has onboard charger inside it?
Yeah, Bajaj is there, I think. And Ather onboard charger is there.
Onboard charger is there. Okay.
Yeah.
How much kilowatt it is?
1 kilowatt.
No, this is, but I'm not sure.
No problem. No problem. No problem. Good. At least you have that information that Bajaj and Ather has got onboard charger. Okay. And what about the Ola, the famous ones? Do they have onboard charger, or you have onboard charger?
Ola have onboard as well as both chargers here.
Is it correct? Ola has onboard charger, offboard charger. Or do they give extension? Do they provide an adapter along with your EV?
That we
Which
are
will
not sure.
actually connect to a AC EVSE, that is a AC supply, and then that adapter itself, which is like a you can say your laptop. Okay, how you charge your laptop? By using the adapter. What an adapter does, it converts your AC to DC. Correct. Okay, so maximum two-wheeler, if you check, they will have this offboard charger. Correct, which is outside the vehicle. Okay, fine. Very few two-wheeler EV you will have, which will have onboard charger. Now, next, power based on the power flow, unidirectional power flow and bidirectional power flow. So today, I'll be covering this in depth. So please be connected with me for next half an hour. Okay, and based on level of charging, you might have already heard from Rahul sir, level 1, level 2, and level 3 based on the power output, also based on the current output. Okay, then based on the cable types also, AC connector, DC connector, that is also being covered by Rahul sir. Okay, so I'll be covering this part, onboard charger, offboard charger, what is unidirectional power flow and bidirectional power flow. And based on charger phase, single phase or three phase. Okay, so first thing, now this picture will give you a clear idea, okay, what components does the onboard charger should have and what component does the offboard charger should have. Okay, correct. And do every circuit which is charging the battery is called charger, or it is called as EVSE. When to call it as EVSE and when to call it as a charger. Okay, now simple. If at all your power source is a single phase AC, if at all your power source is what? Single phase AC. And if you want to charge your battery which is DC, okay, so there your role of onboard charger will come. There your role of onboard charger will come. So in that case, your onboard charger rating will be less because it has to only charge from a lower power circuit. That is level 1. Okay, so your onboard charger will have a rectifier circuit in it. It will have many other circuits, but definitely it should have a rectifier which will convert what? AC to DC. AC to DC conversion should be there in your onboard charger. Correct? Okay, now this equipment which is actually supplying AC, that equipment will be called as AC EVSE. Okay, fine. So in detail, next slide I'll show about AC EVSE. See, AC EVSE I'll show in the next slide. But right now you have to understand difference between an onboard charger and offboard charger. Okay, so your onboard charger first has to convert AC to DC. It can work for level 1 charging. It can work for level 2 charging. Okay, wherein in both the cases, what is the input source? In level 1 and level 2 charging, what is the input source here? What you're getting here? AC, correct. AC. Okay, fine. And now suppose you have a charger installed, okay, for high power output. Suppose you have a 3-phase AC. 3-phase AC, I am actually rectifying it. Okay, I can rectify either after rectifying, I can boost it. Okay, so here only I am getting DC. So if I boost it, I'll get a high voltage DC, whichever is required by the EV. Okay, or else what I can do, I can step up. If I want a high voltage DC, I can step up this three-phase AC by three-phase transformer, then rectify. Okay, and then I can have a high voltage DC, which is required by the battery. Okay, so these two topologies are there. Okay, and in any of this, what is the final output you're getting here? What is the final output you're getting here? DC. Yes, so those vehicle supply equipment.
DC.
Yes, yes. So if vehicle supply equipment gives you a DC output, okay, then the role of onboard charger is not there. Got it? So onboard charger compulsory will do what? AC to DC conversion. Got it? It will have many other components which will, today's session is for that only. In detail, I'll show you all the circuit of onboard charger. Right now, you have to only understand. Yes.
Sir, which equipment boosts the voltage?
It is a DC-DC converter. Boost converter is there. Okay. You have LLC converter. See, if you, that size I said at the start, if you let me complete the session, no, I have everything for you. I have complete circuits for you, which will give you a complete idea what circuits are there. See, this is the final part which I'm going to discuss. Okay, wherein you will understand inside onboard charger what different circuits are there. Okay. Okay. So shall I continue?
Okay,
Yes.
sir.
Yeah. Yeah. So here we are. Okay. First of all, understanding difference between the onboard charger and the offboard charger. Correct? Okay. So onboard charger definitely will be for AC to DC. If you are having an offboard charger, if it is having a DC output, then definitely we call it as DC EVAC. Okay. And this connector plug, whatever sir has told, okay, that will be as per the supply you have available. Correct. If you have a single phase AC supply, this will be type 1. If you have a three-phase AC supply, this will be type 2. Correct. If you have a DC here, so it will be either CCS1, CCS2, or GB/T DC. Okay. Correct. Or CHAdeMO. Right now we have GB/T. Someone asked in the group whether we are using GB/T or not. So under that Bharat DC 001, we are using GB/T for DC. Okay. Right now, remember this difference between onboard charger, offboard charger. If your battery is charging via onboard charger, okay, the power levels are less. Power levels are less. Okay. It will be around 21 kilowatt. Hello. Yeah. If you want to have for more than 43 kilowatt or 50 kilowatt, you can say power output from the charger, then definitely you should go for DC EVAC. Okay, so definitely all AC EVAC equipment will be having a little slower charging than the DC EVAC equipments. Okay, correct? Hello. Fine. Yes. So, sir, can I have an offboard charger for AC? Can I have an offboard charger for AC? Got my question very clearly. Can you have offboard charger for AC?
Yes, we have offboard charger for AC.
That should not be called as charger. Offboard charger for AC, I'll not call it as offboard charger for AC. If I'm getting AC here, I'll always call it as AC EVAC and not the charger. Why? Because you will only have AC, but battery needs DC. So onboard charger has to work. In no scenario your onboard charger and offboard charger will work together. Correct? Okay. Correct. So whenever we are talking about offboard charger, remember it's an AC EVAC and not the charger. And whenever you're strictly saying offboard charger, that means you're telling about this phenomena, this flow process, wherein three-phase AC is there, then they're rectified and boosted to give you the required DC voltage. Okay. Okay. Getting my point? Yes. So,
sir, sorry to interrupt.
Yeah.
Sir, actually, I wanted to ask as you said in Ola bikes, we have like we just felt that it is an onboard charger, but as you said, it is an offboard charger that does the conversion from AC to DC with the help of a connector, right?
Yeah, just like your laptop. Just
Yes.
how you have a laptop, this thing.
So
Okay,
my
adapter.
only question is, after the connector gives the DC input to the battery, then the charging of the battery should be faster, na, sir? Like, why is it taking like 5 to 6 hours?
No, I said Ola, see, maximum you can say have the AC VAC. Okay, correct. And the charger is outboard charger. Two-wheeler I'm talking about, two-wheeler.
Yes, it's two-wheeler only, sir. But
Two-wheeler.
then also it is taking 5 to 6 hours. Then
Yeah,
it should not be the case.
because,
That is-
yes, because the power output.
I think that depends on the C rate.
Yeah, that depends on the C rate. That is one true thing. Second thing is the
Okay.
output power which I have from the charging equipment or the EBS equipment.
Okay.
Okay, my output power is 3.3 kilowatt. So definitely charging time will be more.
Okay. Yes,
Okay, yes. But in two-wheeler, we cannot have this much kilowatt output power.
yes, sir.
Okay, that's why two-wheeler will definitely always take time.
Right.
However fast you are thinking of. Okay, yes.
Yes.
I hope I cleared your doubt.
Yes,
Okay,
yes.
let's go ahead.
Thank you, sir.
So this is the difference. This one more slide will give you clear difference between AC VAC and DC VAC. Here, this is your vehicle. Okay, this is your vehicle, EV. Correct. Okay. Now, if you check this, here the connectors are there, correct? AC or DC. So vehicle do not know from which type it is going to get charged. Okay. So if let us say if it is charging from the AC VAC. So from AC VAC, depending on the power level and the you can say whether it is single phase AC, whether it is three phase AC, you will have a connector. Okay, correct. And that connector will be mapped with this vehicle, correct. And then you will have an onboard charger. So whenever AC VAC is there, definitely your onboard charger will take in the role and then it will start charging via BMS. So BMS is also there. Okay, correct. So BMS will take care of the charging protocols and all, and also whether it is under voltage, over voltage for battery protection. So whatever is required for battery protection, BMS will take care. Now, right now, understood this one thing? Whenever AC VAC is involved, onboard charger has to play the role. Okay, correct? Okay. Now, when DC VAC is there, then directly see this line indicates how the DC is flowing. Okay, so from here you get a DC. And that DC via BMS. Now, BMS will always be there, whether it is via onboard charger or whether it is directly from the DC VAC. Clear? Only thing now this will be in picture. Clear?
So can you repeat for AC VAC?
Yeah. See, if at all you are getting power from AC VAC, okay, your AC is available here. So your onboard charger has a more role over here. So the onboard charger are designed in such a way, whether you are charging from the home AC supply level 1 or whether you are charging from outside AC VAC level 2, its rating will be designed in such a way that it can work on both the levels. Why? Because moment you are having AC VAC, the conversion of AC to DC has to be done by the onboard charger. Got it? Understood this? So I never call this as offboard charger. So that creates confusion between offboard charger and onboard charger. I always call such thing as AC VAC. Why? Because you do not have rectifier. Okay. If at all directly DC I am getting, then what is the use of onboard charger then? Got it? Understood one flow, AC VAC, connectors, onboard charger, battery. Then if it is direct DC, okay, then DC VAC, okay, BMS and the battery. Clear? Okay, let's go ahead. Now this is one AC VAC. Okay, now what is the major difference between EVAC and the charging circuit? Okay, so AC VAC, generally we are designing it for two major purposes. One major purpose is data logging. If a customer is charging from your AC VAC, how much energy is consumed, okay, for how much time it was connected, okay, Fine. So for how much means the billing purpose, data logging purpose. So that is one main role of your AC EVSE. Second main role of AC EVSE is what? Your protection. Your vehicle protection, charger protection, personal protection. So all this protection should be there in your AC EVSE. Like here, you can see MCB is connected and RCCB is connected and SPD is connected, research protection device connected. Okay, so if you see, majority is devices are for protection and for data logging and identification. Got it? So this is how AC EVSE looks like. In practical also, I can show you. At the center only I'm here, so I can show you the AC EVSE. Just for 1 minute, so that practically you can see. Okay. Okay, I'll stop presenting the screen for some time. And I'm pinning my screen here. Okay, beta. Yeah. Can you see my screen? Yes. Yes, sir. So this is how.
Yes, sir.
This is what your AC EVSE practical looks like. Okay. Now it's a 3.3 kilowatt. Is it visible? Yeah. It's a 3.3 kilowatt. Now here we are making it for, as you can say, for student safety and all. It is looking like you can say a bigger one. But industrial, if you go, it will be a smaller. You can say smaller size. Okay. Correct. Okay.
Sir, screen is not.
Now it's visible.
Yes.
My AC EVSE is visible now.
Yes.
Okay. Fine. Yes. So now what is this G2V and V2G? Okay. So first we will discuss about G2V, that is grid to vehicle. Okay. So now this is your AC EVSE, correct? Okay. So AC EVSE, then the onboard charger, then the BMS and battery. So definitely it is like a little bit slower way of charging. Okay. So from grid 3-phase AC, okay, you will have 3-phase AC. Okay. Or you can have single phase, depends on what. Who will tell me now? Depends on what, whether this part should be single phase AC or 3-phase AC. Depends on what? Depends on the connector which you're using. Correct. Okay, whether this output should be single phase, 3-phase, depends on which connector is available here. Okay, correct. So that depends on which kind of AC you are available here. And it's not a big thing. You can have a, from 3-phase, you can have a single phase connection. Correct.
But
Just,
connector is same, na? Almost 3-phase and single phase. But I'm talking about the 62196 part is same, na? I mean, the L1, L2, L3 is same, but there is a connection for L1.
Yes.
That is different thing. But L2, L3 also present. That is not connected.
if you go for IC 60309,
Mm-hmm.
IC 60309, it is only for single phase.
Okay, but I'm talking about the IC
Different.
connector, which is follow the IC
Type 2.
62196.
That is type 2.
Yeah, type 2.
Type 2.
Exactly.
Correct. Yeah. So that's what. So we have both. Correct. 62192 and 60309. 60309 type 1, and that is type 2 you're talking about.
Yeah.
Correct. Okay. So that's what I'm saying. So that depends on what kind of supply is here. Okay.
Yes.
So
Yes.
see, you can see the role of onboard charger. Okay. Now
Yeah.
see, in the DC EVSE part, DC fast charging, you will not see the role of onboard charger.
Yeah.
That is very clear from today's session, correct?
Yes.
When the onboard charger will come into picture, when the onboard charger will not come into picture. Okay, fine. Obviously, the onboard charger cannot handle that much power which your DC fast charging is giving. Okay, more than 45-50 kilowatt. Okay, fine. Okay.
But
so,
I have a question, but just I'm waiting for you. Let's just complete this session, then we will discuss in QA session. Yeah.
Thank you. Thank you.
Yeah.
Okay. Yeah. Yes. So now we have this two chargers based on power flow. Correct. You remember the flow chart which I at the start which I showed. So I'm discussing that in detail. So you have a unidirectional charging, correct, and you have a bidirectional charging. So what happens in unidirectional charging? what happens in unidirectional charging here? You have a grid, okay? The grid range is coming to your house, single phase AC or three phase AC, because if you have a three phase, you have applied for three phase AC, then you can also have a three phase AC at house. Okay, correct. Some people use it for motors and all, pump motors and all. Okay, fine. So for here again the same thing, single phase or three phase, then definitely this is called AC VSC, and you will have onboard charger here. That is called unidirectional. Okay. Now suppose if my you can say house supply phase, okay, correct, and my battery is charged, but I cannot utilize the power of your battery to give it to my house. Why? Because it's a unidirectional charging. Now, what is bidirectional charging, also called as V2G or V2H? Here, the charger circuit, okay, whatever you are using charger circuit, okay, that charger circuit has got ability to transfer bidirectional power flow. Means your power can be transmitted from your house via this charger to the electric car. Also, it can be delivered back when suppose the house supply fails, okay, and if you want in an emergency, if you want supply to be there in your house to some point, not all, okay, so that also can be taken from the vehicle battery using the bidirectional charger, and your home can get a supply. So this one diagram will give you a little idea how it is done. Okay, so suppose now here you have a DC solar panel, okay, you have a DC solar inverter. Your house can get the supply, uninterrupted supply from the solar panel. Okay, this is one way. Okay, now this is single way. Arrow is single means what? You cannot give supply to the DC solar panel, definitely. Okay, so you are only getting power from the DC solar panel to the house, unidirectional flow. Now that whatever power you have in your AC, okay, either from the grid or from the DC solar panel, that can be used to charge the vehicle. Okay, and this bidirectional EV charger can also give it back to the grid. Okay, it can also give it back to the grid. Just give me two slides, 2, 3 slides later. I have explained everything, how it gives back to the grid. Okay, so that is called V2G or V2H, vehicle to grid or vehicle to house. Okay, so let's go ahead. Yeah, so here one more diagram, if you check, it clearly specifies what's the difference between a onboard charger and offboard charger. So in C, single phase or three phase AC. So if you have a AC, your onboard charger will come into picture. Okay, and inside onboard charger, you have these many things. Okay, inside onboard charger you have this. Okay, you have a EMI EMC filter, then a power factor correction circuit, okay, and a DC-DC converter. Okay, and here only when you are talking about PFC, no, here only you have AC to DC. After filter only you have AC to DC. Getting my point? Okay, so here I can add up one more block. Like, okay, here what they have assumed that PFC inside PFC only you have AC to DC converter as well as the power factor correction purpose. Okay, so moment you have a AC here, till this block you will have a DC here. Okay, getting the point? Onboard charger. Okay, now check, similar things are there in the offboard charger. But what might be difference then? What might be difference?
Onboard is within the EV itself.
Yes, that's a great thing. Correct. It's very simple answer. Correct. One onboard is inside the EV, offboard is outside the EV, and the power rating. Though the component or the, you can say, stages of power are same, like protection unit, EMI EMC filter, PFC corrector, DC-DC converter. Okay, so though the stages look same, but the power rating of these devices is less than the power rating of the offboard charger, which is giving you the DC fast charging.
In case of OBC, that is AC level 1,
Yeah.
what about the isolation?
Yeah, that is here. Okay, you have a dual active bridge, okay, or full bridge, phase shift, full bridge transformer. Okay, see here. Here in this circuit I have already explained. You are acting about, you actually want to know about this. Correct? Yes. So this will
Okay.
provide the isolation. Yeah.
Yeah.
No problem. No
So
problem.
OBC have the
Yes.
isolation. OBC
If
also
it is,
take care the,
yeah,
yeah.
isolation is required, as the OEM specifies, they design as per that. And generally it is required compulsorily for the bidirectional converters.
Okay.
Okay, when you are having V2G kind of thing, then definitely you should have this dual active bridge. Okay, fine. Yeah. So I hope this is clear to you. Okay, onboard and offboard in detail. Generally,
Sir, in PFC, after the EMI filter, we will have AC. Then means it will.
no. After
PFC
AMI filter, this PFC, whatever they are writing, no, there. What this author wants to say here is that PFC includes everything, rectifier also, okay, and the power factor corrector also.
Sir, but like it will do the power factor correction of the AC supply, right, to unity, and after that it will convert it to DC, right?
I'll answer everything.
Okay.
Just let me come to this slide.
Okay.
Trust me. Let me come to this slide with waveform. I'll explain with waveform.
Sure.
Okay. Fine. No problem. No problem. I'm happy that people are curious, and that means they are glued to their seat. Okay, good. But just have a patience. I have answer to all your queries. Okay, let me complete. I hope this is clear now, at least, with some extent of doubt how this is done internally. Okay, that also I'll clear. Okay, so understood what is happening inside in an onboard charger and offboard charger. Okay, only thing power level is different. Okay, so this is onboard charger, offboard charger. You can see same kind of thing. Rectifier, I guess we are getting your kid's voice also. Someone just message her. Yeah. Okay, now it's okay, I guess. Okay, so either you have an onboard charger wherein you have a rectifier, then DC, and here see, it is like simple diagram they have shown, but it's not that simple. There are so many components and so many stages. Okay, that's what the stages were shown in this diagram. EMI, EMC filter, PFC. Okay, and in fact in DC-DC converter also there are stages. Okay, so let's go ahead. Yeah, now see, so many kind of DC-DC converters are involved here also. Correct. Here in the onboard charger there is a DC-DC converter if it's a bidirectional. Okay, and here in offboard charger also you have a DC-DC converter. In motor also there is a DC-DC converter. In motor controller also you have a DC-DC converter. Why we need this? If you have a bidirectional DC-DC converter, means what? The regenerative energy which you are having, 5% at least, so that should be transferred from motor back to the battery. Okay, for that you have this. Okay, so wherever bidirectional converters we are talking about, it will have a DC-DC converter. Okay, and this will act like an inverter now. Okay. Yes, and one more DC-DC converter, it was not mentioned in the previous slide. What is that DC-DC converter? Which you know easily, and which you know the type of the DC-DC converter. Step down, or we call it as buck converter. Okay, so this figure will give you clear idea. Okay, correct. Fine. So what this it is doing? It is having a bidirectional converters. Okay, wherein you can have power from AC supply, and your battery can be charged to DC. Okay, and now again, if you want to give it back to the grid or the home, okay, that can also be done from here. Okay, so battery can be made to charge like this and made to deliver like this. Got it? And also battery can also deliver in this way also. Got the flow? Okay, so for that we need this bidirectional DC-DC converter. Okay, and here this is for auxiliaries. This is for auxiliaries. Got it? Okay, so with this, I'll go for this main slide now, which you are waiting. Okay, so this is your onboard charger, onboard bidirectional charger. Now, how this works? Now, first thing, why we need is EMI EMC filter? Okay, so you might have known whenever non-linear loads are there and whenever switchings are involved. See, so many MOSFET switches are involved in DC-DC converter, correct? Okay, so AC to DC converter also, and DC-DC converter, wherever you have MOSFET switching at a high frequency of 50 kilohertz and more. So what can happen? It may create some electromagnetic interference. Okay, fine. Or also we don't want electromagnetic interference to enter from the grid side also. That's why that's the use of this EMI-EMC filter. Okay, so if this is AC, so here the output is also AC. So till this point, what is my input now available? AC. Okay, now this bidirectional AC to DC converter, okay, it is actually what? It is a rectifier. Okay, it is a rectifier. Okay, also in some cases, if I add 1 or 2 circuits more, it can be your AC to DC converter along with AC to DC converter along with power factor corrector. Along with power factor corrector. So that can be done if I change this switches by something called as gallium nitride switches. Okay. So these are fast, you can say fast acting switches. Okay. So either this switches or this switches. If you have a PFC along with it, so you have this kind of structure. Okay. So what it does, simple. What it does, I just want to rectify my AC. Okay. Along with power factor. Now you say, sir, if you are having DC output, why you need power factor correction? Okay. Now simple. If I take a simple rectifier I'm answering to one of the questions which someone asked. Okay. Fine. So now this is my AC supply. Am I right? And this is my DC output. Clear? DC load. Okay. Fine. Now, can anyone tell me what is the current waveform over here? If it's a full, you can say full wave rectifier, correct? This is a diode-based full wave rectifier. So what is this waveform? Can you tell me? Without filter, without filter. Simple. This is the AC here. This is the AC voltage. AC
all settings.
Voltage.
All settings.
Yes, that means it is like this. It is like this.
Yes.
Correct. Okay.
Yes.
Okay. Now what happens? Now if I have a another switching like thyristor or you can say MOSFET switches, and if my load is not resistive, if it is inductive load, what? Inductive load. So what happens? Inductive or capacitive load, we call it as generally non-linear load, also acts like a, you can say, inductive or capacitive load. So what happens here is in the AC supply here, the current waveform is somewhat like this. AC, AC current waveform means here at this point. At this point. Getting the point? Okay. So this is called peaky current, which actually includes so much of THD, something called THD. THD means total harmonic distortion. So this kind of waveform we don't want from the AC to be drawn, from the grid to be drawn after the EMI-EMC filter. Got it? So that's why we need PFC. Okay. So what PFC does is the PFC tries to smoothen this. Okay. And you may have something like this, but you will have AC. However the load is. Got it? Whether it is capacitive load. See, because here we are charging DC link capacitor. I hope the question was asked by someone like how this PFC is required and all.
Yes, yes, understood.
Yeah, okay, okay. Thank you.
But what is the topology to smooth this AC waveform? That is the just reduce the angle between voltage and current only. Yeah, any other topology to reduce? Yeah, to smooth the AC waveform.
This bridge, whatever you can use, is called totem pole. Totem pole bridge. You can search on the net also totem pole bridge. What the totem pole?
No. What I'm asking,
Yeah.
Like you are saying that is a spike if I using inductive or inductive load after the MOSFET IGBT any switching. Okay, that is inductive load is given in the AC line. Okay.
Okay.
So you can try to smooth this AC line because that is not our required waveform. So if we go to the if we use a PFC before fed to the MOSFET, like before fed to the H bridge. Okay. So what is the topology? That is consider the as per my knowledge, that is the voltage or current consideration, the angle between voltage and current. We try to reduce the voltage and current through switching the MOSFET. So that we can do in designing the PFC. Apart from any other advanced technology to doing this, modify the angle, control the angle between voltage and current.
Okay. Wait. Just have some thing with me. Okay. Fine. Just wait a second. Oh, I guess
because we need to try to modify control the cos phi.
Yes, definitely. I have. Don't worry. I just yeah. This is the thing actually. What you were asking and what I was telling. Okay. So this is the topology used. Okay. Fine. It's not like normal your S1, S4 will conduct for one cycle and then S3, S2 will conduct for other cycle. No. The switching is done. Okay. See, in CCM mode they call it. Okay. You can read here CCM mode. So in this CCM mode, if you do, then your PFC will work in that mode. Okay. Fine. Continuous current mode we call it as. Okay. So in this action takes place for some part of the duty cycle. Okay, this switch will be conducting. For some part of the duty cycle, your capacitor will charge as a DC link. Okay, and for again some part upper two switches, and then this. Okay, but since we have only limited time, I restricted myself to not go into that detail. I hope you got your answer. Yes, sir. Hello. Am I audible to all?
Yes, sir.
Yeah.
Sorry. Actually, I'm in mute. Understood. We will discuss later. You can continue here.
No problem. But I hope you got to know. Like
yes, I got my answer. But फिर भी मैं एक बार discuss करूँगा आपसे one to one.
No problem. Yeah. Okay. So till here, what you have understood in the onboard charger is how the DC is charged. Now let me complete now, please. There are only few slides remaining. Okay. Yeah, I'll take all your questions, don't worry. Okay. So here you have a DC voltage. Okay. Correct. So your after EMI-MC filter, then your totem pole bridge having a PFC. Okay. So you have a rectified DC. Okay. Now, just to have a bidirectional DC-DC converter, okay, you have an isolated structure. This is called isolated DC-DC converter. Okay, dual active bridge. Okay, or you can also have phase shift full bridge. Okay, so what happens in this bidirectional DC-DC converter is first you convert this DC to AC. Okay, which will flow through this high frequency transformer HFT. Okay, fine. Now there are several topologies. I don't have that time right now to teach all those topology right now, but yes, you will get to know in our courses all these topologies properly. Okay, so right now this whatever DC is there, that is again converted to AC. Okay, and again that AC is again converted to DC. So why? If I have DC here, why not that DC given directly to here? Then that is not the case of your bidirectional DC converter. Got it? Okay. After EMI-MC filter and PFC, totem pole bridge and PFC, directly whatever DC you have, if you are using it for charging the battery, then definitely that is your unidirectional charger, onboard charger. But if I want bidirectional charger, you have to have this bidirectional isolated DC-DC converter. So what we do is we use the concept of something called as phase shift. Okay, got it. So between these two voltage levels of this side AC and this side AC, okay, when you want power flow, pay attention. Now, when you want power flow from this direction, that is from grid to vehicle, okay. So the phase shift of the transformer is adjusted as such. The power is drawn from the grid and it is actually charging the battery. Okay, and when you want V2G, again the phase shift of the transformer is adjusted so that the power is taken from the battery, and the switching is done as such. The power is fed to the DC link capacitor, and again from DC link capacitor it can go to this EMI-MC filter. For all that, what you need is the control topology of microcontroller, which will do all this, or the DSP, which will do all this. Okay, got it. So what is there in your onboard charger? You have EMI-MC filter, you have a rectifier along with PFC, correct? And then if you want it to be bi-directional, you have a full phase shift or dual active bridge. Okay, correct?
So presently in offboard charger, the PSF be the topmost advanced topology, yeah?
Correct. So same kind of topology will be there in the offboard also, but the power rating will be different. Got it? Okay, so onboard charger, same you are looking at EMI-MC filter, rectifier, correct? Then the DC bus, then the bidirectional DC-DC converter. Same thing will be there in your three-phase offboard charger, but the power rating will be okay. Yeah, so this is one sample image of the onboard charger. Okay, there are so many companies, so many manufacturers. You can have different images of each. Okay. Yeah. So last part, that is what once you have studied all this EV charging system. Okay. So what opportunity you have in this either in the entrepreneurship role or in the job role. So we have classified into this two part. One is the entrepreneurship. Okay, how you can earn money by using this EV charging system. So one thing, if you have a land, okay, which is nearby highways or where you have a high density traffic, okay, you can actually collaborate or have a word with this EV charging setup companies like Tata Power, Static, Charge Zone, Relux, okay, and you can make them, you can see install their charger at your place, and you can earn from them. That is one way, okay, which needs very moderate investment. And the second one is you install your own charger. You install your own charger at the places, okay, and give it on lease or give it on monthly rental, okay. That means pay per use. Pay per use model means what? Okay, you want to use my charger, okay, you're most welcome. Doesn't matter whether you're from that campus or outside that campus, doesn't matter. Only thing, you have to have a recharge plan. How many time you want to recharge your vehicle from that. So that kind of charge as a service model you can utilize.
But is the government have any plan to like for the personal, yeah, any public want to install a charger? Because
Yes.
we don't have a server now, so how we can charge this? Like one person take 10 kWh power from my charger. So how customer pay to me? That is per kWh is 20, per kWh is 30. There is no rules from government side, no?
No, you have, you see, you have an AC, EVAC equipment, suppose. Okay, fine. So you are not having, for this, suppose you're not having the fast DC charging, correct? Okay, you are talking about what society, housing societies and ID parks?
No. I'm talking about the Tata Power. They have their own server, own CMS. So
Correct.
according
For data
to
line,
this Tata Power demanding, like end of the charging, the charger send the meter value to the server and the server calculate the amount. Okay.
Correct.
But if I want to install a charger in my premises, so I basically मैं कोई server नहीं लेंगे ना, तो मेरा
not
चार्जर
required, not required. See, if you have your HMI inbuilt, okay, which is well advanced with data logging also.
yes,
So see, I'll show you. In our case, no, this AVAC is there. Okay. Yeah, this one. So can you see this
Yes.
HMI over here?
yes.
Okay, so this HMI has all the data logs.
No, no.
And those data
That
logs.
I understood. My question is different. Okay.
Let me complete. Sorry. Because questions are always welcome, but let me answer it first. So what happens here is inside there is a control card. Okay, in that control card you have a memory, okay, which actually stores the data, and that data can be wirelessly transferred to any place, any server, any mobile data if you want. How many people have charged and all. Okay, correct. And what it takes to build up a site, you have a WordPress.com. You can have your own website and you can link that HMI address over there, so you can get it. How many customers are charged from your this thing? Okay, or you can have a prepaid one. Means you can program this HMI in such a way, okay, that if anyone puts this much amount, okay, you have to the relay will be only activated for that much particular amount of time. That's so simple. I hope now your question is answered.
Okay, but my question area is quite different. That is
why, because we have not shown you internal part of this. Once you, have you already enrolled in our course? Like
yes.
Yeah. So is it which month? First month, 6 months, 7 months?
It's at 1 month, just January.
Yes. So still way long to go to come to this part wherein we will have a workshop and wherein you will meet us, and then definitely I'll tell you how it works and how the data logging takes place and how the billing is take place.
No, that I have some elementary idea. I'm not expert, but I have an idea how the metering is.
Nobody's expert. Nobody's expert here. You all are in learning phase every time.
But my area is like मेरे पास एक चार्जर है, मैं बिलिंग किस बेसिस पे करूँ, क्योंकि मैं ऐसा कस्टमर से पर यूनिट में 40 रुपया 50 रुपया डिमांड नहीं कर सकते ना, मेरा जेल हो जाएगा। मैं वो कहना चाहते हैं कि मैं मीटरिंग कैसे करूंगा, दैट इज डिफरेंट थिंग। वो तो ठीक है, वो तो टेक्नोलॉजी हिसाब से होगा, दैट इज आई नो, वी विल डिस्कस लेटर ऑन दिस, बट स्टिल गवर्नमेंट हैव नो प्लान कि अगर एज ए एक्स पर्सन ही इंस्टॉल ए चार्जर इन योर प्रीमिसेस, तो वो चार्जर को अगर कुछ पावर बेच रहा है किसी ओईएम या किसी व्हीकल ओनर को, तो व्हीकल ओनर किस बेसिस पे उसको पैसा देगा? मैं 20 रुपया चार्ज करूं पर यूनिट, 30 रुपया चार्ज करूं, 40 रुपया चार्ज करूं, ऐसा कुछ डिफाइन नहीं है स्टिल नाउ।
दैट सी अभी क्या मार्केट में कॉम्पिटिटर्स नहीं है, जब कॉम्पिटिटर्स रहते हैं तो डेफिनेटली आप अपना चार्जिंग पर यूनिट कम ही रखेंगे, करेक्ट? ओके, और इसमें आपका दो चीजें इन्वॉल्व है, आपको पर केडब्ल्यूएच कितना पड़ता है,
नहीं वो तो है, बट स्टिल इसमें कुछ लीगल इंफॉर्मेशन होना चाहिए ना। गवर्नमेंट पूछ सकता है ना तुम किस बेस पे अभी 30 रुपया ले रहा है।
गवर्नमेंट अगर टू बी ऑन द फनीएस्ट पार्ट, वैसे तो गवर्नमेंट अडानी वन को कभी नहीं पूछता कि समोसे आप फ्लाइट के इधर 200 रुपए 300 रुपए क्यों लगाते हैं, वैसे वही समोसा वो बाहर से 40-50 रुपए में लेके आ सकते हैं, तो पता है। There are many things, there still standardization is yet to come, but yes, जब तक गवर्नमेंट से एक सेट काइंड ऑफ रूल्स नहीं आते तब तक जो भी पहले उतरेगा ये फील्ड में वो ज्यादा पैसा कमाएगा। दैट्स व्हाट आई कैन टेल यू इनडायरेक्टली। ओके फाइन, आई होप यू गॉट माय पॉइंट इन अ ह्यूमरस वे।
it's your no issue.
Okay, I hope everyone understood this part, and actually the entrepreneurship part I have already discussed, what ways you can earn money, and the second one is job related. Obviously, so many companies are working in the charging development, charger infrastructure development, hardware.
Sorry, in between मैं तिलक बोल रहा हूँ। In between.
ये last slide है। Let me complete this, and we are open for anything. Yeah. Okay. Yeah. So hardware and software development. Okay. Then charging infrastructure development, operation, research and development, sales and business development. Okay. Now sales does not mean हम लोग कुछ साबुन वगैरह बेचने का बता रहे थे। नो, व्हाट वी आर टॉकिंग अबाउट इज द चार्जिंग इक्विपमेंट सेल्स, करेक्ट? ऑन बोर्ड चार्जर सेल्स हो सकता है, यू कैन go to companies to company, you can work under them, okay? You can work in private sector, you can work in government sector, Energy Efficient Study Limited. Okay, they are also working on how to implement this DC fast charging and what kind of connectors are more suitable for Indian vehicles. Okay, so startup companies like Static and Charge Zone, wherever you have seen the charger installation. Okay, so that companies you can work it. So you have two ways: either you can go for entrepreneurship and earn money if you have some land or something like that, or second way is you can try having a job in this sector. Okay, so this is the future in your EV charging system. Okay, so with this, now we are open to any discussion. Now, yes,
Excuse me, sir.
yes. Now you
So for the franchisee model, about how much investment would be required?
how much investment means now that depends on how much kilowatt charger you want to install.
So let's say for level 3.
For fast charging,
Yes, sir.
for fast charging, definitely you will require anything between 12 lakh to 15 lakhs. If your system is so sophisticated. Okay.
Okay,
Correct.
sir.
So
Taking
we
care
for
of many
60
things.
kilowatt.
Yes.
For
Okay.
60 kilowatt. If you are going above 60 kilowatt, then the cost will
Cost will
be so high.
increase. Yes, correct. That's what. No, so whatever is the charger output level, charger output power, that will decide how much is your infrastructure cost. Correct, Ankit? Ankit asks, no,
Okay.
I guess.
Yes, yes, sir.
Yeah. Okay, yeah. Correct, Ankit.
Yeah, so that is my last question.
Yeah.
I understood the topology for the AC and DC both, but
Okay.
my question is the control pilot for AC charger and DC charger. That is clear ki when OBC is present in the vehicle, that time AC charger fed to the power fed to the OBC and OBC directly connected to the BMS. That is clear for the power line. Now I am talking about the control pilot like CP. So in
Yes.
AC and DC both have present CP. Okay.
Correct.
So
Correct.
in
Correct.
case of DC, is the CP line connected to the OBC? Yeah, it also directly connected to the BMS.
CP line has to be connected via BMS only. Okay.
For
Correct.
AC charger, like
See-
for AC charger means I am talking about the level 2 charging. So OBC is inside. So in case of AC charger, CP also directly connected to the BMS, via through OBC.
Via, see, listen, now whenever you are having AC, correct? Actually,
Yes.
I have slides, but right now I have to search a lot because I've got so much data. But yes, I'll let you know. See, OBC is involved only when you have a level 1 or level 2 charging.
Yeah. Now
Correct.
that is clear in power line. That is very
Yes.
clear in me.
Correct.
That is in power line.
Correct.
The AC power is directly fed to the OBC,
Yes.
and the OBC is connected to
Correct.
the battery through BMS. That is very clear.
This
But
CP,
my question is for
I'll tell you.
DC CPS.
Yeah.
Please.
So the CP control pilot, no, you have a separate supply. Okay, correct. Which will actually take care of the contactors which are connecting to the battery. Okay, EV contactors which are connecting to the battery. Okay, so moment your control pilot will have the coordination with the BMS. Okay, this will give a signal. Okay, start charging. If you have okay, let me show you the CHAdeMO. From CHAdeMO, you will have a clear idea.
No, if you show me the CCS2, that is better for me because India don't accept the CHAdeMO. I know it's going to CCS2.
Okay.
Sir,
Okay.
please stop and other persons have get chance to ask questions.
Oh, yeah, that's also true. Pratap ji, you can connect me separately. I have all
Okay.
the answers, whatever you
Okay.
want.
Okay, please.
I have all the answers. Don't worry. Okay. Only thing, yes, because what happened? No, out of 100 people, if we only communicate, then some people.
Understood. You can go ahead. No issue.
Yes. So sorry, sir. But yes, I have answers for all your questions. Don't worry. Okay. Yes. Anyone else?
Sir, I want to ask what is the difference between DC charger, positive and negative? Positive DC current and negative DC current.
Positive DC current and negative DC current.
DC current, yes, sir.
No, actually, you want to say whether contactors are utilized in both the lines, positive line and negative line? So yes, I'll say yes. Correct.
Sir, but what use and how it works, and what is the main difference between this positive DC and negative DC current? I asked.
No, but generally what we think about is whenever you have a source, okay, battery, fine. Okay, so
Yes.
whatever current is sent from the plus has to reach minus. Then the circuit will not be complete. Now, if I only have one, if
Yes, sir, yes.
current is going out from the plus terminal of the battery, it has to come back to minus.
Yes, sir.
Okay.
Because it's seems like in diagram and waveforms of DC, it's
So-
not possible, sir.
No, not like that. Actually, you may have been confused between these contactors. Okay, on which line your contactors will be there, like that. Okay, I'll get back to you on this. Don't worry, Swapna ma'am.
Yes, sir.
Okay,
Yes.
yeah. And anyone else? Yeah. Yes. No, knowledge.
Yes.
Someone.
Hello.
Sir, hello.
Yeah. Yes, I got.
Sir,
see,
मेरी voice जा रही है सर?
हाँ, yes. पहले तो कौन लगता है? दो लोग
सर,
हैं।
my question is
हाँ, विवेक जी बोलिए।
विवेक।
Yes, बोलिए।
सर, मेरा पहला क्वेश्चन था कि वायरलेस चार्जिंग के बारे में आपने बताया है, तो वो किस रेटिंग तक रहेगा, उसके अलावा इफिशियंसी कितनी रहेगी उसकी, और
मैंने
वो
I guess-
बेसिकली स्पेस
हाँ।
कितना स्पेस के लेवल में
Yeah.
वो क्या रहेगा, मतलब कि क्यों हमें वो यूज करना चाहिए, नहीं करना चाहिए, हाउ कैन वी डिसाइड टू यूज दिस टाइप चार्जर?
ओके, ये जो है वो शायद प्रताप करके कोई है, उन्होंने भी सेम क्वेश्चन पूछा था, उसका मैंने आंसर दिया था तभी। मैं फिर से रिपीट करूंगा वो आंसर। जनरली जो इंडक्टिव चार्जर है आपका, हाँ, इंडक्टिव
सेकंड
चार्जर जो
क्वेश्चन
है,
आप एक बार
wireless charger।
उसको भी आप कर लीजिए।
हाँ,
ओके,
पहले मैं ये बता दूं आंसर।
माय सेकंड क्वेश्चन। हाँ, यस सर, यस।
Okay, so the inductive wireless charging generally is meant for 30 kilowatt to 100 kilowatt. Okay, but right now the research is still going on to make it to 300 kilowatt, and the efficiency of inductive charging is 85%. But there are also capacitive wireless charging who are not up to that scale. Okay, because of the dielectric effect, so dielectric losses. So generally that is around 10 kilowatt to 15 kilowatt max capacity. Research is going on for that also, but efficiency, if you talk about inductive wireless charging, have got more efficiency. That is your first answer to your first question. Second question. Now you can ask second
Okay,
question.
my second question is LLC चार्जिंग। जैसा कि आपने दिखाया LLC चार्जर के बारे में कि आपका बैटरी चार्ज
Correct.
करने के लिए
Correct.
PFC सेक्शन है, सेकंड है कि DC सेक्शन है।
Correct.
तो उसमें आप
Bidirectional,
LLC
correct.
और PFC में बेसिकली जो PFC हम डिजाइन करते हैं उसमें मेंस की जीरो क्रॉसिंग सेंसिंग करते हैं, और जहाँ पे हमारा जीरो
Yes.
आता है उस
Zero voltage.
पॉइंट पे हम
Correct,
स्विचिंग
correct.
नहीं कराते हैं, अदर लोकेशन पे स्विचिंग कराते हैं,
Zero
बूस्ट
current
करते हैं
switching,
वोल्टेज को।
yes.
तो आपने
जिसको हम रेजोनेंट कन्वर्टर बोलते हैं।
तो आपने
रेजोनेंट कन्वर्टर बोलते हैं।
जी
हाँ, ये बोलिए।
तो एक बार सर ना उसके बारे में एक बार एक्सप्लेन कर दिए। बेसिकली क्या है कि हमें डिजाइन करना है एलएलसी चार्जर, और उसमें
Okay.
विथ ZVS जीरो वोल्टेज स्विचिंग एंड
Zero
जीरो
voltage
करंट
switching.
स्विचिंग,
Correct.
both are
Correct,
available
correct,
in LLC design. So how can
Correct,
we
correct.
use and how can we start designing in LLC charger?
See,
Sir,
in
kindly define in Hindi, sir.
Okay. Now see, LLC converter, what you're talking about, no? Correct?
Yes, sir.
Yes. Yeah.
Yes.
Let me use one slide to answer you. Okay. Now see, you want to design ZCS or ZVS. Okay, correct.
Yes, sir.
Correct. So now in this first you will talk about
Yes.
the power level. How much power level and how much voltage level you want your OBC or onboard charger, offboard charger you want to work. Correct. Power level and voltage level. First you will decide that. Then generally for designing of any and then some percent depend on your design, 2%, you can take 1 or 2%. 2% of this max.
One second, we lost your voice.
Now I guess, but it's okay for all. Is it only for you or for all? Hello?
I also have the face.
All.
Yeah, so again I'll repeat it now.
So we have a class right now.
Yeah, okay. So now this output current, whatever is flowing in your socket, you need to consider for designing the inductor, you need to consider 2% of the ripple. Okay, and based on the inductor ripple, you decide the value of L. Okay, and then whatever is your V out max. Correct, based on the output voltage max, and again considering some percent of ripple of that V out max. Okay, you design your capacitor. So generally, capacitor and the switching frequency obviously plays an important role. So there are two major factors for inductor design. One is the ripple you are considering, okay, based on the voltage level and ripple you are considering, and the switching frequency Fs. And for capacitor design, how much is the output voltage maximum you are expecting, percentage of ripple which is flowing to the capacitor, okay, fine, and the switching frequency Fs. So Fs will also play a role in designing this LL and C component in this LLC resonant converter. Okay, got it. So because your resonant converter is also called soft switching, correct? Soft switching. So what is soft switching? We are trying to identify. So your various sensors will be required. Current sensor will be required, correct? Battery, I battery current will be required. Okay, so you join our course, you will get to know everything in detail. Yes, how to design this LLC converter also. But since this webinar we have kept for only 1 hour, so many things we have to cover. I know that is not sufficient time, but yes, if you pitch it up, we can take it further in the next webinar.
Okay. So basically, we have read in LLC designing as per reference design, switching duty cycle is fixed to 50%. So how can we control output voltage and current to by feedback?
Yeah. We are back. Yes, I hope. Sorry about the network problem, but yes, I hope you got
Sir,
whatever explained.
बेसिकली जो जितने भी मैंने रेफरेंस डिजाइन रीड किए हैं उसके अकॉर्डिंग वो 50% ड्यूटी साइकिल ओपन रहता है. तो अगर 50% ड्यूटी साइकिल रहता है तो हाउ कैन वी चेंज फ्रीक्वेंसी फॉर output voltage start soft start and control output feedback voltage and current both are.
Yeah.
और
so उसके लिए
how to decide to range switching frequency range 100 kilohertz to 500 kilohertz. What is the range required? Maximum to minimum range.
That's what. How much is the power level? How much is the power level and voltage level you are expecting? That first thing you have to consider. Okay, how much is the power level you are designing for the onboard charger and offboard charger, and what is the voltage level you are considering? Okay, and based on the power level, then you can think about the switching frequency. Okay, so your component do not become bulky. See, nowadays in OBC, onboard charger, offboard charger, you need high power density. What do you mean by high power density? High power density means that you need to have a maximum power in very small space. The component should not be bulky. Correct. The reason for using DC-DC converters everywhere in OBC or onboard or offboard charger, reason for using DC-DC converter is this only, that you need high power density and high efficiency. Okay. This is a very never-ending topic and very vast.
1 minute.
Yes.
1 minute. Yeah.
Yes.
My name is Pondian. I am from England.
Yeah.
I work for Driver and Vehicle Standard Agency for the Ministry of Transport.
That's great to hear, sir. That's really great to hear.
And also, I authorize the new vehicles to go on the road, which is called IVA, that individual vehicle authorization. Okay.
Yes. Good to have you here, sir. Good evening.
Previously, I worked for the switch mobility. I
Okay.
think you know what is mean by that. It is Ashok Leyland and
Okay.
the EV project. Okay,
Great,
so
great. I know.
fully,
Yes.
yeah, I fully understand what you said. But two things. One is, when
Yes.
you charge, when you do the fast charger, the
Okay, sir.
battery packs, battery
Okay.
comes with the individual cells. In the
Okay.
fast charger, some of the cell, it won't be filled up. So it will trigger the fault code. For
Okay.
that, we need to shut down other cells to charge the particular cell. Do you got any program for that? Second one, in England, because I got the electric car, which is given by the government, okay,
Okay.
for my work. So very soon, the government going to put the fuel tax for the electric cars, because many people they're going to use the electric car. The government is
Okay.
not getting the fuel tax. In India, if they're going to do that, what will happen to this business? Can you please answer for that?
Yeah, those questions are very, you can say, interesting, whatever you have asked. Okay. Regarding the first question, okay, regarding filling it, the cells which are not charged or having some fault. Okay, there is a fault code you said.
Yes,
Hello?
it should be the 5% plus or minus. That only SOC is takes only average. It doesn't take the full the reading for each cell. It takes the average plus or minus 5. If it is the less than 5%, the individual cells, it will puts as a fault code. Then the vehicle goes on the limb mode. So vehicle won't have the pickup. So for that, you need to put a override program to charge the particular cells. So you need to identify the cell and need to charge the particular cell. Otherwise, when you plug the charger, every cells will get every cell should come under the equal level. Otherwise, it won't charge.
But
But you
that,
can see SOCs on the dashboard. You can see it is charging, but it won't charge.
but now that depends on what kind of BMS topology you are utilizing. Do you have master slave BMS configuration?
No, I'm
Having each
talking.
slave
Yeah,
BMS
we
for
got
every module, so that will actually make our task of troubleshooting easier. Correct? Fine. If your module for identifying such cells, okay, if your module has a slave BMS, okay, and if it may you can say checks the voltage levels, okay, it can
Yes.
really indicate, okay, where
No,
which
just a customer comes to me and he is complaining vehicle
yes,
is fully charged, but
okay,
it got a limb mode, but you can see on the dashboard
okay,
it will come on the battery warning sign, which means it's a low battery sign. Okay,
okay,
normally
okay,
the customer thinks the vehicle need to be charged,
okay,
but when they
okay.
put the charge, vehicle won't charge.
Okay, so that means the master BMS programming, okay, which is
Yeah,
coordinating with CAN communication with the slave BMS, okay, that
yeah,
programming need to be checked again.
yeah. That
Whether
only.
yeah,
Do you give the package along with your training?
that we will design, definitely. We can design such thing for you.
Okay, thank you. The
Okay,
second question,
thanks.
the
Yeah,
tax.
yes, okay. That now as a trainer, I can't commit on this or
Because
do any, yeah. Okay,
the
it's a
next
big
year,
thing
the
of government.
budget,
Yeah.
next year budget, England want to impose the fuel tax for the battery cars, the EV cars. Okay, if one country stops, other countries will follow because everybody want to have the revenue.
Okay. No, but
So
they will
what
come
will
up.
happen to these ministers?
No, but EV will sustain, sir. Till
But yeah,
15 years from here on, I'll promise you have my word. EV will sustain by
no,
because the
I
need of
know
our
very well. I know very well
need of
because
our.
I told you I worked with Ashok Leyland, the EV project, the double deckers, the buses.
That's
So
great,
I
sir.
know
Please.
full that. So and also I'm in individual vehicle authorization person in the Manchester in
Okay.
the DVSA and plant. So I know
Okay.
fully. But these two things only I want to ask. Okay, thank you.
Yeah,
It,
but I
it
hope
was
the first question I answered to your satisfaction, sir.
yes, yeah.
First,
It was very wonderful program.
thank you.
Thank you.
Thank you so much, sir. Thank you for kind words of appreciation. Thank you. And be connected to us for further such things. Yeah, I guess lot many doubts we have taken. I guess it's too late now. With session was originally for 1 hour. If you have still doubt, you can mail us. Okay, mail our team, and we will take it up personally, and we will answer you. Okay. Yes.
Yes, sir. Thank you.
Yeah. Thank you, ma'am. Thank you, ma'am. Thank you.
Great, great, great.
Thank
Great,
you.
Prasad, sir.
Thank you. Thank you so much. Thank you so much. Thank you so much for your appreciation.
Prasad
Thank
sir, sorry to interrupt. One last thing
Yes,
I
yes,
want to add in
yes,
this.
sir.
Yeah, all the past participants, this is a request for all of you. I have pasted a link in the chat box that is for the feedback and also for the certificates. So please fill that form and just submit it so that you will get your certificates. And also please give us your valuable feedback so that we can try to get these webinars on a much better way. We can deliver that to you, right? And I hope all of you were able to get something out of this webinar, out of Prasad sir and from me also. So I would like to thank all of you on behalf of whole TIY team and on behalf of Prasad sir and on my behalf as well. Thank you all for joining in. Please do fill the form.
Yeah. Thank you, everyone. Do fill the form for your certificate. Okay. And tell others also who were there initially. Yeah. Okay. The form link is already mentioned in the group, okay, in the chat. Fine. Okay. So kindly fill it up. Rahul sir, just pin it. Can you just
Sir,
pin the
I
link?
did pin. I'll put it again. Once again, I'll put it.
Pin it so that like how I pinned. I'll remove my pin. Okay. Yeah.
Sir, I've pinned it.
ও তো আর ফোন কিছু করলো না, ওর তো ফোন করার কথা না। আমি তো দিয়েছিলাম দেরি হবে।
Okay, Rahul sir, can I leave? Yes. Anyone from the tech?
Yes, sir. Good night.
Good night. Good night. Thank you, Jishan. Thank you.
Okay, sir. Thank you all for joining. Thank you so much.
Thank you, sir.
Thank you, sir.
Hello, anyone audible? Guys, anyone there? Hello? Pratap, my voice is audible? Hello?
Yeah, hello, sir. Hello. Hello.
Yeah.
আমি তো 7 দিনের জন্য বানিয়ে রেখে দিই, তোমরা হয়তো রেখে দিতে পারো গরম ভাতের সঙ্গে কিংবা রুটির সঙ্গে রেখে দিতে ভালো লাগে। তার জন্য একটা গাছের চালে নিয়ে নিলাম 2 চামচ লবণ, 1 চামচ চিনি, বেশ খানিকটা কাঁচা লঙ্কা, তার মধ্যে দিয়ে দিচ্ছি 1 কাপ ভিনেগার আর 1/2 কাপ জল। এরকম ভালোভাবে রাখিয়ে নেবো। এবার এর মধ্যে দিয়ে দেবো গাজর, বিট আর পেঁয়াজ। তার জন্য গাজরের খোসা ছাড়িয়ে নিচ্ছি, বিটেরও খোসা ছাড়িয়ে লম্বা লম্বা করে কেটে দিচ্ছি। একটা পেঁয়াজও দিয়েছি। তোমরা চাইলে বড় জারে বেশি করে তবে রেখে দিতে পারো। আমি ছোট জারে রাখি বলে অল্প অল্প করে সবজি নিয়েছি। তোমরা চাইলে শুধুমাত্র পেঁয়াজও এইভাবে রেখে দিতে পারো। পেঁয়াজ খাওয়ার পরে মধ্যে যে একটা গন্ধ বেরোয় সেটা এভাবে খেলে বেরোবে। এবার সব সবজিগুলো ভিজে যেন জলের মধ্যে দিয়ে রেখে দিলাম। একদম পরটাই কিন্তু খাওয়া যাবে, খেতে খুবই সুন্দর লাগে। একটা টক টক ভাব আসে আর মিষ্টি ভাবটাও আসে, তাহলে তোমরাও করে দিতে পারো। দেখেই এত লোভনীয় লাগছে, তাহলে খেতে না কত টেস্ট হবে। তাহলে আসুন ফটাফট দেখুন আর কালকেই ব্রেকফাস্টে বানিয়ে ফেলি। 1 বাটি কড়াইশুঁটি মিক্সি জারে দিলাম, ওর মধ্যে আদা, কাঁচা লঙ্কা, অল্প জল দিয়ে একদম মিহি করে পেস্টটা তৈরি করে নিলাম। ফ্রাইং প্যানে 1 টেবিল চামচ ঘি দিয়ে দিলাম 1 বাটি সুজি দিলাম। তারপর হ্যাঁ বলো স্কুটিটা একটু দেখাও বাজার যাবো।
আচ্ছা আচ্ছা
ঠিক আছে।
আরে ঘরের ভিতর স্কুটিটা আছে, মাকে বলো বের করে দিবে।
আচ্ছা ঠিক আছে। আরে বাহ, তোদের স্কুটিটা একটু বের করে দে। স্কুটি তো ঘরে নাই, নয় নিয়ে পালিয়ে গেছে। দিদি বলে দিবি, না বলার কি আছে? ওই না,
হ্যাঁ বলো।
তোর স্কুটিটা একটু দেখাও বাজার যাবো।
আচ্ছা আচ্ছা
স্কুল এখন 8টা আর 30 পরে স্কুল এখন 8টা আর 30 পরে আমরা তো বালিশের কভার ইজি ভাবে পরিষ্কার করতে পারি, কিন্তু বালিশের ভিতরের কভার কি ইজি ভাবে পরিষ্কার করতে পারি? চলো আজকে দারুণ একটা ট্রিক দেখাই। এরকম একটা গোল ঢাকনার সাহায্যে আমরা এই বালিশের কভার পরিষ্কার করে দেখাবো। ঢাকনাটার উপরে ভালো করে রুমাল পেঁচিয়ে তার উপরে দেবো ডিটারজেন্ট পাউডার এবং খানিকটা জল। ভালো করে এভাবে ঘষে নিলেই পরিষ্কার আমাদের ভেতরের কভার। দেখো কতটা চকচক করছে। তোমরা অবশ্যই বাড়িতে এইভাবে একবার ট্রাই করে দেখতে পারো, কিন্তু আমার অনেক উপকার হচ্ছে। আশা করি আপনাদের অনেক অনেক উপকার হবে। আমরা তো বালিশের কভার ইজি কি মনে হচ্ছে এটা চকলেট নাকি অন্য কিছু? চকলেটও না অন্য কিছু না, আমি আপনাদেরকে বলে দিচ্ছি। এটা আমি জাপান থেকে ইউটিউব করে নিয়ে এসেছি, একদম খাঁটি ঘিরা, যেটা আসলে কখনোই বাংলাদেশে পাওয়া যাবে না। তো আমি কিন্তু প্রাইস অনেক বড় লোক পেয়ে গিয়েছি এই ঘিরাতে। প্রথম যেটাতে আপনাদের কি মনে হচ্ছে এটা চকলেট? এর প্রথম দেখবো চেষ্টা করে যায়। আমি যেন সেরা অপরের উপাধিটা পাই, চেষ্টা করে যাচ্ছি আজকে 24 বছর এতদিনও সেরা উপাধি হতে না দেখলাম। চেষ্টা করে যাবো আমি আবিষ্কার হয়ে, এতদিন নিজের মুখে সেরা উপাধি সেই কোনো চার বেলা 24 খাবার বানায়, খাবার খেয়ে এবার মুখটা খুশি করতে চায়। খুশিগুলো কিনা আসলে আজও বুঝি না, চুপচাপ খাওয়া দাওয়া করে বেরিয়ে যায়। চল্লিশ রকম খাবার আছে, জামা কাপড় ধোয়া আছে, তার বিছানা পরিষ্কার করে দেওয়া আছে। শুধু কি হাতের কাছে জামাটি হাতের কাছে দিয়ে আমি তারপর গাড়ির চাবি হাতে ধরি দিই, জলের বোতল ছাতা ওয়াটা সব কাছে দিই, তারপরে হাসি মুখে টাটা করে দিই। এও সে একদিন টাটা বলে না তো, তারপরে ঘরে ঢুকে নানা রকম পথ বানাই, দেখি খাবো বলে চিন্তা করে থাকি। অনেক ভাবে শোনা বিকালে এইভাবে শোনা, তাতে কি খাবে শোনা কিছু খুঁজে পায় না। যা বলি যখন বলি আমি শোনা তখন আমার বলে তুমি যা সেটাই করো, যা সেটাই কি রান্না আগে সচেতন না বলতে পরে বলে এটা কি রান্না, এই ভেবে ভেবে যাই সারাদিন আমি। তারপর বলছি আমি পোস্ট যাই, এই দেখে লোকে বলবে দিদি কি আমার দিলে, এছাড়া কিছু তো খাবে না আমার সব জানি যে মুখে করিয়ে না। রোজ দিয়ে দিন দিয়ে চা দিয়ে খাবে, 7 দিনে 7 রকম খাবার চাইবো না, এক খাবার যদি করে তোলে না। সকালের পাঁচালির মতো দুপুরের পাঁচালি যদি শুনতে চাও, কবে বছর প্রথম দিন দেখে চেষ্টা করে। তাই আমি অক্সিজেন ব্রেকে বা কাজ করার সময় বলার আর লাগবে না, কারণ এখন প্রতিটা মুহূর্ত হবে বলার আর তখন এসে অক্সিজেন ব্রেকে বা ট্রাভেল করার সময়
আমার মনে এত বছরের বোঝাটা আমি না
এটা কোনো সাধারণ গল্প নয়, এটা একটি
ম্যাডাম, আমার মনে হয় না দেরি করা উচিত হবে। এক্ষুনি থানায় গিয়ে আমাদের ফোর্স নিয়ে বেরোনো উচিত ওনাকে খোঁজার জন্য। হ্যাঁ হ্যাঁ।
হ্যালো মা, কে ফোন করেছিল জানি না পুঠি, তবে অভিষেকে কিডন্যাপ করে কোথায় রাখা হয়েছে সেটা জানালো। আমাদের এক্ষুনি বেরোতে হবে। এক্ষুনি চলো। আমার মনে হয় এই মেলের মধ্যে না সিসিটিভি ফুটেজটা রয়েছে। অর্পণ চালাতো মেলটা, তাহলে বুঝতে পারবো কে সেদিন সন্ধ্যাবেলা ফোনটা করেছিল। কি করি এবার?
সাবস্ক্রাইব করুন এবং দেখে নিন লেটেস্ট এপিসোড।
আমার মেয়েটা আজকে একটা নতুন জীবন শুরু করতে চলেছে। তুমি দেখো আমার মেয়েটা যেন সারা জীবন খুব ভালো থাকে। প্রত্যেকটা মেয়েটা গেল কেন?
সাবস্ক্রাইব করুন এবং দেখে নিন লেটেস্ট এপিসোড। সাবস্ক্রাইব করুন।
আমার মনে হয় এই মেলের মধ্যে মা, কে এটা লগ্ন বয়ে যাচ্ছে। চল।
কেউ হয়তো টাকা লাগিয়ে কাউকে লাগিয়ে ভালোবাসা দিয়ে আটকে রেখো।
ম্যাডাম, আমার মনে হয় না দেরি করা উচিত হবে। এক্ষুনি থানায় গিয়ে আমাদের ফোর্স নিয়ে বেরোনো উচিত ওনাকে খোঁজার জন্য।
স্বপ্ন পূরণের অঙ্গীকার। যে টিম হয়ে যাবে উইকেট সেটা, তারা হয়ে যাবে সানলাইট টিম অফ দি উইক। এভাবে যে গোটা সব থেকে পেয়ে যাবে তারা হয়ে যাবে সানলাইট। রাষ্ট্রের পক্ষ থেকে অনেকের জন্য আছে 10,000 টাকা চেক। উদ্ধশ্বাস একটা পর্ব আজকে আমরা কাটালাম। আপাতত আমাদের সারেগামাপার এই সিজনের গ্র্যান্ড ফিনালেতে জায়গা করে নিয়েছে জাভেদ বাবু এবং যদি টিম থেকে অনেক জানা। এই মুহূর্তে সত্যজিৎ, আরাত্রিকা, অঙ্কনা এবং সাই তাদের স্কোর সুরক্ষিত আছে খামবন্দি অবস্থায় ওই আমাদের সামনে গ্লাস চেয়ারে। আগামী পর্বে আরো 6 জন পার্টিসিপেন্ট তারা পারফর্ম করবে এবং তারপর আমরা জানতে পারবো যে আর বাকি 5 জন মানে অনেক বাদ দিয়ে আর বাকি কারা যারা পৌঁছে যাবে এবারের গ্র্যান্ড ফিনালেতে। সকলে ভালো থাকবেন, সুস্থ থাকবেন এবং অবশ্যই সঙ্গীতের সঙ্গে থাকবেন। শুভরাত্রি। কেন কেন অভাব এখানে দর্শক হবে ছোট দর্শক
আমার দেয়নি এখন দেবে না এখন ছেলে মানে কোথায় আসছিস তো গান ফান ছাড়ে যা হাত পা ধুকে যা তুই বিচার তো বললি আর এখন দেবো না এখনই বুঝতে পারবি কি হাত পা ধুকে
যা ইচ্ছা খাও, যা ইচ্ছা ঘোরো, সব কিছু করতে পারো। কাজ যেটা প্রথম হিসেবে বলতাম না তোমার কাজ এইটা, মায়ের কাজ এটা, এবার কাজে তোমাকে প্রচন্ড রকম সিনসিয়ার থাকতে হবে, লয়াল থাকতে হবে। তোমার কাজে তুমি যদি নিজের কাছে ফাঁকি মেরে দাও আমাদের আমরা যে কাজে যদি লয়াল থাকে তো বড় হয়ে গেলে അതിനകത്ത് കാലിലൊക്കെ കടന്ന സ്പോർട്സുകൾ പോലെ চলো এবার বিরিয়ানিটা খাওয়া
একটু রায়তা দেয় রায়তা কত খায় এখানে ছাড়তে যা কত রায়তা উলা এও ঠাকুর দেখে রাখো খাবারটা খাচ্ছি না
সব খাচ্ছাই
মা বলে যে খাদের কাছ থেকে কাজ না করে এমনি পয়সা নিলে থাকবে না
আমরা কাজ করে কষ্ট করে নিতাম না
কোথায় কষ্ট করে
আজকে ইনকাম কষ্ট করে করলাম এই যে আজকে যে ইনকাম করলো
আরে ভিডিও করে ঘাটি দিতে হবে বড় যাও ও তো ফোন করে বললো
কেন
ও তো নিজে ফোন করছে
তো
হাত পা ধুলি তো আমার যে টয়লেট পেয়েছে তখন ব্যাগ খোলার পর বুঝতে পারো টয়লেট পেয়েছে আমার ব্যাগ খোলার পরে টয়লেট পেয়ে যায় মা একটু জানাও না বিরিয়ানি শুরু করে না ঢালা বিরিয়ানি চিকেন দিয়ে হাত আমাকে বলে দাও
390 টাকা নেই 115 টাকা পাঁচ 30 টাকা দিয়ে 40 টাকা
মোবাইলটা নিয়ে আসো বাবা একটু নালে ফোন করো ফোনটা বেঁচে যাবে ভালো লাগবে না প্লিজ দাও দিয়েছে রাইতা রাইতা নয় এখানে আমাদের ভালো রাইতা দেখো এখানে
ভালো কোন আস্তে আস্তে কোন ও আসুক তারপরে করবে না কেউ বুঝিয়ে
মোবাইলটা নিয়ে তাহলে একটু ফোন করো
দিয়েছে সাড়ে 5 দিন
तुम भाग सकते हो तुम खाओ ना बोला पड़े खाओ ना मैं हमारे लिए अरे मारे जाके बाकी दे अरे बाकी सलाद सलाद भी आटा बाकी दे कितो बाकी दे डिमो गया बात वाह तू फुले जास बाकी क्या होता है डिमो गया आज का टाइम नहीं डिमो गया बात और की बोलिस एक बिरयानी का एखाने बिरयानी बोले तुम खाओ हैदराबादी कांग्रेस बोलते फोन ये नहीं छोटा होता यार तेरा से कंप्यूटर जब बाबा लैपटॉप आप बोल रहे थे चिट्ठी काम कर एग्जाम मां दाঁড়াও मां दाঁড়াও ওকে তুমি পাঠালে কেন আমি যদি পাঠাই
না
একটু আরে বাবা কিছু করিনি তো আরে বলে কি বেরিয়ে দিলাম apa biryani বন্ধ দাও না এটা খাইছে ও কিছু আগে দাও আইডে ছুটি হয়ে যাবে ছুটি যাবে আইবে না করে দাও আইবে না করে দাও একবার সমান সমান আমার জন্য টক হয়ে গেল দুটো টক হয়ে গেল ও আচ্ছা নিচে পাপা গো নিচে তো ঘি দেওয়া উচিত তাহলে তেল দেয় কেন মানুষরা লেগ পিস দিয়েছে ও তাহলে কি করবো হেসো না কাজ নিতে এবার আজ কেমন করে দেবে সবাই সবাই ভালো দাঁড়ান দাঁড়া আমি এটাকে উপর করে চালু করি অনেক দূর করেছে মানুষ দিয়ে দেখো বিসর্জন ভাবলেন তিন যেমন এটা ভালো আমার একটু দাও বাবু আন্দোলন করতে এখন একটা দিন আছে তখন আবার প্লেট বাকি হয়েছে আগের দিন না তুমি তো আতরটা কম দাও এখন দিতে আতরটা কত লাগে না তোর পড়াই কারণে অনেক ভালো হয় না তুই হলে পাঠা না বিরিয়ানি না ভালো না এবার যে রুটি আছে দিদি কোথায় চলে খারাপ যেতে হবে চিলি চিলি বেশি স্পাইসি করতে বারণ করবো পানিতে পেটে ভরবে বাবা মানে আমি খেতে পারবো না ওরা একদম স্পাইসি ভালো ওরা কম ঝাল করলে ভালো হবে না যেখানে যেতে সেখানে সেটা খেতে হবে তো ওরা কম ঝাল করতে পারবে না ওরা স্পাইসি খাবে হ্যাঁ ওর ওপরে একটা দেখলাম দোকান না হলে আবার বানানে প্রবলেম আসবে তখন থাকতে হবে না আর ভালো করতে হবে ভালো একটু করতে আমি এখন আমরা একটু থামস আপের মতো পায়খানা করছি তাহলে তোরা খুব বন্যায় যাচ্ছিস পরীক্ষা চলে আর আমি যখন এদের কথাটা সব বেরিয়ে যাবে এক করে কথা বেরিয়ে যাবে মাংস আমি একটাই নিয়েছি না, মাংস একটা দুটো দিয়েছে না, তার কিন্তু কটা পাবে না, তুই একটা নিয়ে নিয়ে দুটো দিয়েছে, আবার কি কম দিয়েছে, একটা দিয়েছে না, মা ওই সাতটা বলে সামনে সেটাই কমপ্লিট সেটা সাত পেয়ে যাচ্ছে টাকা পেয়েছে মোহনা বলতে টাকা পেয়ে খুশি হবে টাকা টাকা ধরা না দেখো ওরা সেই দেশে আনতে পারবে মোমো সবাই করতে পারে না কারণ এরা পাহাড়ের লোক বোঝাই যাচ্ছে তো এরা জিনিসও ভালো বুঝতে পারে বলো 10 মাসে রাখতে হয় আপনি কোনো গাছের জন্য গাছের জন্য মোমো খানা বড় মোমো এইগুলো কালি দুধের अब तो सब फैशन হয়ে গেছে সব মোমো স্টিমার দিয়ে ইয়ে তো বলছো না ওদের থেকে তো দেখি মোমো নিয়ে বসে আছে 7 টাকা पे তো কিগুলো ভাবি তো খা না ये खाना खाना মোমো করে দে সব জায়গা স্টিমার করে দিয়ে হ্যাঁ বলতে হবে বুঝতে পারছো এখন এখন কোও দিবে মোমো তো ট্রাই ছিল না খাটা হচ্ছে মোমো পাঁচবাতে আকাশ ইয়েতে আকাশ লজে ছিল ওখানে মোমোটা আমার দুয়ার সাইডে ভালো লাগে এরপরে তো বাবা দুটোই ভালো আলু পোস্তা ভাত দেড়শো টাকা কি মরণ করতে পারে দেড়শো টাকা আবার টাকা হচ্ছে কি করে নিরামিষ তো অনেক পদ আছে ফ্রাইড রাইস পনির টাকা দেবে না সব টাকা নেই টাকা সব পর টাকা গুলো মেনশন করে উনি তো গায় অ্যারেঞ্জমেন্ট করছে বাট পানি করে টাকা খুঁজে দিয়ে পয়সা করে মাল করে তোর কাছে কিছু নেই অ্যারেঞ্জমেন্ট কর সেটা দেয়া তো দিতে হবে মাল তো ওই তো না এটা টাকা তো দিতে চাই না এই কথা না কি 150 টাকা করে সেভ করে আর বাবা এসে বুঝি আর দুটো বাদ করবে আর দুটো বাদ করবে তোমাকে জোগাড় করা তো কি এখন ঘরে ঢাকা করা তো মেন উদ্দেশ্য আর আমি তো
अरे बोलो
তার তো ওই তো মাকে ঝালা ডাল আছে দিনের বেলা হয়ে যাবে আর তো ডালটা করে চাপ ডাল আছে তারপরে ডিমান্ড দাও আগে কি কোন ছিল
बस 8:15 शुरू করেছে কোথায় একটা থেকে আরেকটা ক্লাস সকাল 8:30 বাজে আর আরেকটা ক্লাস করবে
আমি তো বলে যে আপনারা করব না আমি বলে তখন বলে করব না এটা বলে ডিমান্ড দাও
ना एक क्लास করতে দেরি করে দাও শেষ হয় ক্লাস অ্যাকচুয়ালি না এটা
What?
ओके आपका सेम है लग चलेगा
Olivia, कितने का भी है
आजकल मैसेज तो इंडियन न्यूजीलैंड का कितने यार तो इंडिया न्यूजीलैंड बदल से
আফগানিস্তান
তাহলে ইন্ডিয়ার সঙ্গে দক্ষিণ আফ্রিকা
আজকে জিতে যায় আজকে জিতে যায়
আগে জিতে লাস্ট লেস কে খেলা
আরে আমি খালা আরাম জায়গা করে
वो प्लेयर जे एक नंबर थी सेकंड नंबर ग्रुप प्लेयर 2 नंबर थी वो प्लेयर जे 2 नंबर थी सेकंड और काल के मैच इंडिया जीते जाए
আর বড়
दो और एक नंबर थी
আর বড় কথা খারাপ নাম নাই করে
ग्रुप एक नंबर टीम था जो प्लेयर 2 नंबर थी नंबर 2 नष्ट हो गया ग्रुप दिए थे हाईएस्ट टीम में लोग खेलते हैं तो जैसे
আর খালা তো মনে করবে
और काल के दिन हमारा नहीं चलेगा
মেজা না
मेरा
আর আপনি লড়া হুয়া
इंडिया में अच्छा लग रहा है और दक्षिण अफ्रीका से खेला ये फाइनल में बात की है खेलना तो साल रहेगा
ফাইনালে উঠে যাওয়া মানে তো সবই পাবে, কিছু টাকা মন পাবে আর প্রফিট পাবে, বাকি সবই পাবে। লেভেল পাবে, ম্যানেজার ক্যান্সেল আর ভালো খেলবে চলে আসে।
তোমার হিসেবে যেটা চলে ওটারে তো হ্যাঁ, কিন্তু যদি ইন্ডিয়া প্লেয়ারও তো জানতে পারছে না এটা যে জিতলে অস্ট্রেলিয়াটা, আর ইন্ডিয়া যদি প্লেয়ার জানতে পারছে না ওরা আর
তোমায় আমি কি বলবো, উদাহরণ একটু আগ কি কখনো ভাই খাই তখন বেরিয়ে ওরা খেলতে নামলে বেকার জন্য।
আর ওদের কিভাবে দিয়ে দিতে টাকা আমাকে পাঠাতে যাচ্ছে। It's the subscription for it. What is the subscription for it? Now you can tell. You can tell. It's also. I like when I'm like. I like when. আরাম করে মাসে যত ইয়ে করে সেটা তো রাস্তা দিকটা ভালো ইয়ে করে দিবে আরামসে
পরেও খুব টেনশন যোগা হয়ে গেছিল, যে যোগা করছিল খুব টেনশন এগিয়ে পড়ে না বিয়ে করলাম বাবার সঙ্গে তো শুনলাম না যে মানে বাড়িতে আসা আসি হয়ে গেছে।
তাও 2 মাসের মতো তারপরে তোর কথা শিখতে হবে 2 মাসের অঙ্ক